would be recorded for the format given by the AICTE ATAL authorities. It is for your concern that all the sessions will be in the recorded mode. Thank you.
Ma'am, your mic mute.
Principal sir, kindly permit me to move.
Yeah, please go ahead.
A very good morning to all the dignitaries. I, Dr. A. Krishnamanjari Pawar, Coordinator of the Faculty Development Program. It gives an immense pleasure to invite you to participate in the AICTE Teaching and Learning Academy sponsored online 5-day faculty development program on Internet of Things, Revolutionary Impact on Pharmaceutical Education and Industry, to be held during 21st to 25th September 2021, organized by AU College of Pharmaceutical Sciences, Andhra University, Visakhapatnam, Andhra Pradesh, India. I profusely thank the Government of India, authorities of AICTE, along with ATAL Academy for sanctioning the FDP. I would like to thank the Honorable Vice Chancellor, Andhra University, a visionary leader, a great inspirer who always strives hard for the betterment of the university, Professor PVGD Prasad Reddy sir, for encouraging us in conducting the FDP. I would like to convey my regards to Professor K. Samantha Madam, Rector, Andhra University, and thankful for her encouragement and continuous support. And I thank Professor V. Krishnamohan sir, Registrar, Andhra University, for providing the facilities to conduct the FDP and always encouraging us to conduct various academic activities. Now, I would like to thank Professor Y. Rajendra Prasad sir, Principal, AU College of Pharmaceutical Sciences, Andhra University, for his continuous support in conducting the program and keeping us in a positive mode always. As a pharmacist, this 5-day FDP program would be one of our Pharmacist Week celebrations. Andhra University is not just one of the oldest educational institutions in the country, but is also the first to be conceived as a residential and teaching cum affiliating university, mainly devoted to postgraduate teaching and research. The people of the state have an emotional attachment to the institution since it came into being after a prolonged and collective struggles of the Telugu elite for a university in the educationally backward northern Sarkars and ceded districts in the erstwhile Madras Presidency. Andhra University was constituted in the year 1926 by the Madras Act of 1926. The 94-year-old institution is fortunate to have Sir C.R. Reddy as its founder Vice Chancellor, as the steps taken by this visionary proved to be fruitful in the long run. Former President of India, Dr. Sarvepalli Radhakrishnan, was one of its Vice Chancellors who succeeded Dr. C.R. Reddy in 1931. The university has well-experienced and expert faculty known worldwide for their research contributions. There are 354 professors, 198 associate professors, and 115 assistant professors serving in the university. Organization of international and national events in a regular feature of the university. There are more than 2,500 support staff working in the university. Andhra University is the second institute in the country to start pharmacy courses at university level in 1937. The pharmacy courses were initially offered in the BSc Honours degree of Chemical Technology and as a specialization at MSc Technology level. The importance of pharmaceutical sciences led to the formation of a separate department in 1951. With the commencement of B.Pharm program with the late Professor Rangaswamy as founder, head of the department, the M.Pharm program was started in 1954. A separate faculty of pharmaceutical sciences was formed in 1975. The department has been elevated as Constituent College of Andhra University in August 2006. At present, the department offers B.Pharm, PharmD Postbaccalaureate and M.Pharm and PhD programs in 8 specializations, namely Pharmaceutical Technology, Pharmaceutical Biotechnology, Pharmaceutical Chemistry, Pharmaceutical Analysis, Pharmacology, Pharmacognosy, Pharmacy Practice, Regulatory Affairs. The department has the distinction being the first in the country to start Pharmaceutical Biotechnology Division. Professor S. Rangaswamy and founder faculty members Professor V. Subbarao Garu, Professor N. Viswanathan Garu, Professor K. Samamurthy Garu, Professor E. Venkatrao Garu led solid foundations and molded the department into one of the best colleges among the country. Eminent teachers and researchers have served these departments. The alumni of the department are holding high positions in prestigious national and international bodies, drug industry, drug control administration, in universities in India and abroad. A good rapport is being maintained between the department and its alumni. The alumni formed an association named AUPACT and has established an industrial pharmacy unit in the department in 1998. The faculty of the department has shown their commitment and dynamism by conducting a number of workshops, national and international seminars and conferences, and also the prestigious Indian Pharmaceutical Congress twice in 1977 and in 1995. We always strive for the benefit of the student community and pharma research community to achieve a better society with good education and leadership qualities. This FDP will help us to inculcate the multidisciplinary bridging between the science and the information technology IT, a rare combination of science with the IT that's truly impacting the revolution in the field of Internet of Things and artificial intelligence in the current scenario. It is my proud privilege to invite the speakers of today's session. The first session, History and Evaluation of IoT Basic Applications. Dr. Koduru Suresh Garu, Senior Solution Specialist, Industries and Customer Advisory, SAP Labs, India, and PVN Pavan Kumar Garu, Senior Director and Chief Expert, Product Management, SAP Labs, India. The second session, Internet of Medical Things, Emergence into Different Health Spaces by Dr. Shiva Reddy Challa, Research Collaborator, Department of Cancer Biology and Pharmacology, University, Illinois, College of Medicine at Peoria. Third session by Technologies and Sciences Associated with IoT and Pharma Sector by Mr. Amal Raj, Sivogo, Head Fitted Solutions, Private Limited, Founder, the DigiFact Services, Private Limited, OutSystems. I invite faculty of AU College of Pharmaceutical Sciences and faculty from private colleges, government institutions from AP and other states across the India. I also invite postdoctoral fellows, research scholars, and all the delegates who are with us for this 5-day faculty development program. It is my immense pleasure to invite the faculty members of our college, the Assistant Principal, Dr. Ishwar Kumar Garu, BOS Chairman, Professor V. Girja Shastri Garu, Faculty Chairman, Professor Girija Shankar Garu, Dr. Shailaja and Dr. Molli. With all the good encouragement and cooperation of our institute authorities and beloved participants, we are truly happy that the sessions of this FDP would surely help you all in the required aspects of the subject. I request all the participants of FDP to utilize the sessions given by the eminent speakers to upgrade your knowledge and to actively participate in the session discussions. I would surely promise that these 5-day FDP would help all the participants to inculcate and practice all the practical aspects in addition to their academic curriculum. Thank you so much. Sir, now I request our principal to kindly speak on the occasion.
Esteemed officials from AICTE New Delhi, invited speakers of the day, my colleague and coordinator of this program, Dr. A. Krishnamanjari Pawar, my other colleagues of the faculty, fellow participants across the country, a very good morning to you all. At the outset, I welcome you all to this 5-day faculty development program sponsored by AICTE Teaching Learning Academy, popularly known as ATAL, on the Internet of Things, its revolutionary impact on pharmaceutical education and industry. A topic of immense importance in the present context. If you look at the vision of Andhra University, as I see right now before me, to create new frontiers of knowledge in quest for development of a humane and just society. Is it not a new frontier of knowledge using Internet of Things in the which creates no doubt a revolutionary impact on pharmaceutical education and industry? As I understand, the Internet of Things, which describes the network of physical objects which are embedded with sensors, software, and other technologies for the purpose of connecting, exchanging data with other devices and systems over the Internet. It may not be necessarily IoT just alone as far as pharmacy is concerned. More of IOMT, which is emerging as an area of interest, which is the Internet of Medical Things, which again is an application of IoT for medical and health related purposes, data collection and analysis for research and monitoring. The IOMT has been referenced as smart healthcare as the technology for creating a digitized healthcare system connecting available medical resources and healthcare services. Another one is artificial intelligence, again emphasizes the development of intelligence machines which are widely used in pharma sector nowadays, thinking and working like humans. For example, speech recognition, problem solving, learning and planning. This FDP also aims hands-on training to participate to all the participants for softwares such as ATBD, CAD, design of experiments, micromeds, lexicomp, epicorrates, etc. I have no doubt that the participants will richly get benefited from the sessions spreading over these 5 days. And Pawar Madam has already elaborated what Andhra University is today. It is almost nearing its centenary year, starting way back in 1926. Andhra University College of Pharmaceutical Sciences in India is the second oldest to offer pharmacy education to the country, next after Banaras Hindu University. The visionary Vice Chancellor, Professor C.R. Reddy, in his first Vice Chancellorship, invited eminent persons as faculty members across the country that created really excellent ecosystem in pharmacy, having invited Professor Srinivasan Rangaswamy from Tamil Nadu, who is a direct student of Professor T.R. Seshadri, the only FRS till very recently, who took his PhD under the Nobel laureate Robinson. And then these people uh, deputed the faculty member of the first generation to different countries for pursuing PhD. And this enabled to create a strong research environment in pharmacy college at Andhra University. This has led to the to tell you development of one of the two drugs so far discovered in India. I may remind you, in spite of crores of amount spent on laboratories like CSIR laboratories, Central Drug Research Institute, etc., no effective drug so far has come into the market except two drugs, one from Andhra University Pharmaceutical Chemistry Laboratory, the drug perovskite from the pods from the seeds of Tibetia nerifolia. The other one is from Punjab University, Chandigarh, by Professor Harikishan Singh, which is a neuromuscular blocking agent, chandonium iodide. These are the only two drugs to tell you. The other drugs, whatever they claim, is not a single drug entity. It is a combination of extracts or combination of this or that, no longer existing, but still peroxide is being used in Italy, like digoxin we use in India in the congestive heart failure. So that was the reputation the university is having, and I request the AICTE to sponsor many such events like this one, for which we are very grateful, keeping in view the history of this college, the contribution it has made to the public in the health sector, and I really thank the AICTE for giving us readily this faculty development program and AICTE ATAL. And without taking much of your time, I request Dr. Pawar to go ahead with the introduction of the speakers. I am very happy to learn that today we have four important speakers. One is TVN Kumar, Director and Chief Expert Product Management, SAP Labs India. Dr. Koduru Suresh, Senior Solution Specialist Industries and Customer Advisory, SAP Labs India. The third one is Dr. Shivareddy Challa. He is our own student. Recently, I met him at University of Illinois when I went there and saw the excellent cancer cell biology laboratory, and they are doing really wonderful work on brain stroke mechanisms. And another student is also there, Dr. Krishna Kumar. Both are doing wonderful work. I met them recently at their College of Medicine at Peoria. And then you have Mr. Ramal Raj, COO, Head Fitted Solutions Private Limited founder, the Digital Services Private Limited OutSystems. So I hope all these four speakers will give valuable talk, and you will all get richly benefited from their talks. So I now request Dr. Krishnamanjari Pawar to go ahead further on the introduction of the speakers. Thank you. Thank you.
Thank you, sir. Thank you so much. Sir, dignitaries of the sessions and participants, I would like to announce a great thing today. The three sessions speakers are of the alumni of Andhra University. I am proud to be the alumni of Andhra University, and it is from your side also. So now I take the proud privilege to introduce the speaker of the session, Dr. Koduru Suresh Garu, who will be sharing his experience and expertise to all the participants along with Mr. PVN Pavan Kumar sir. Dr. Koduru Suresh ji is a senior solution specialist and expert with industrial IoT and security at SAP Labs India. He is a seasoned professional focused on product strategy, definition, and go-to-market activities. Dr. Suresh Garu has pursued his Doctor of Philosophy in the topic Green Internet of Things for Intelligent Enterprises from the Department of Computer Science and Systems Engineering, Andhra University, under the able guidance of our Honorable Vice Chancellor Sir, Professor PVGD Prasad Reddy Garu, Andhra University. Having an extensive experience for more than 14 years in solution management and working with global customers in emerging and developed markets, Sir's expertise is in the area of Internet of Things, security and sustainability. Dr. Suresh Garu is an active contributor in the topic of IoT and security in various international forums and also with standards working group like IEEE, Springer and ACM. He also acts as an evangelist by frequently guest speaking in various forums where he talks about Internet of Things and security solutions and shares its concept and educates the audience to understand its relevance in the current digital era. These forums range from academia to corporates to startup and to industry forums. Along with public speaking, he has also shared his vision about IoT enterprise practices in several blogs and external publications too. Apart from his excellence, as I have been in touch with Sir since couple of the months, he is an simple, humble, very cooperative and encouraging towards us. Thank you, sir. We are glad to have the eminent people for the first session of our FDP on History and Evaluation of IoT Basic Applications, Mr. Pavan Kumar sir and Dr. K. Suresh sir. I would now take the opportunity to introduce Mr. Pavan Kumar sir to our participants. Here, I read out the brief profile of our speaker. Mr. Pavan Kumar sir, Senior Director and Chief Expert with Industrial IoT Product Management at SAP Labs, India, is a seasoned product management professional focused on product strategy, definition, and go-to-market activities. Having an extensive experience for more than 15 years in building products and working with global customers in emerging and developed markets. His expertise is in the area of Internet of Things, edge computing, sustainability, and analytics. Sir is also an active contributor in the area of IoT to Government of India and also with the industrial bodies like NASCOM, TIE, and standards working groups like IEEE, NSDC, NASCOM, IoT, SSC. Dr. Pavan Garu also acts as an evangelist by frequently guest speaking in various forums where he talks about industrial IoT business, shares its concepts and educates the audience to understand its relevance in the current digital era. Along with the public speaking, he has also shared his vision about IoT enterprise practices in several blogs and external publications and recently co-authored a book on IoT and edge computing. To his credit, he was recognized as the IoT thought leader of the year at national level by IET India. Very recently, PVN sir made into the top 25 influencers list globally for IoT published by the analyst firm Analytica. Thank you, sir. Thank you so much. Now the platform is yours. I welcome you, sir, for your session.
Yeah. So am I audible?
Yes, sir. You're pretty audible.
Yeah, thank you, ma'am.
Yes, sir. We are able to see your presentation, sir.
Okay, thank you, ma'am. So thank you, ma'am, for providing this opportunity, and we are definitely humbled with your introduction. And I would also like to thank you, our principal sir, and also to Andhra University and team for facilitating these sessions. So if you see today, right, every business or organization, whether it is an emerging or a mature, right from it could be any IT landscapes, right, and these IT landscapes cater to multiple processes, be it like attendance to time recording, travel booking to the settlement, or procurement to replenishment process, or transportation. It could be, I mean, there are several examples. These are a few to state here. So in today's talk, let us understand the overview of Internet of Things or the IoT platform, and how these platforms are actually turning these enterprises and industrial processes much more intelligent, intuitive, and interconnected. So as we are already done with the introductions, maybe quickly I'll move on to the agenda today. So today we'll start with understanding what is Internet of Things and how it is actually evolved over last few decades. And later we will also discuss on various user segments that are available in Internet of Things, followed by the technology stack in Internet of Things, which is one of the key for having the IoT application being deployed in any environment today. So once this is covered, right, we will look at what is consumer IoT and enterprise IoT with a few business examples. So after this, right, we will talk on the technology ingredients of Internet of Things and see how these are actually tightly integrated. And once this is done, later we'll discuss on some insights on edge computing, followed by the enterprise IoT use cases, and understand like how these are adapted in business scenarios. At the end, right, if time permits, we can have a short quiz where we can see and understand like what are the different aspects we covered in this presentation today, and we can also take some questions at the end. So meanwhile, right, during my presentation or Pawan's presentation, if you have any specific questions, like generic questions, if there are any, you can also type in your questions in the chat, and we'll definitely try to answer them. Just in case, right, if these questions are, I mean, whatever you're pasting it, if they are covered in coming slides, we'll ignore them. But if there are some generic questions which will not be covered in these slides, we'll still give an attempt to answer them to you. So let us see what are the interesting facts we have in Internet of Things today. So the term Internet of Things was actually coined by Kevin Ashton while working for Procter & Gamble in 1999. So, but according to Forbes, 17 years later, that is until 2016, there are 87% of people actually have no idea of what Internet of Things means or what it stands for. So the concept of a network of smart devices was actually discussed in 1982 with a modified Coke machine at Carnegie Mellon University, becoming the first internet connected appliance wherein it is able to report its inventory and whether newly added drinks were cold or not, and so on. But however, right, people say that still say that the roots, right, the roots of IoTs go back even further. Like according to Intel, right, ATMs were the first end user oriented elements to be connected online back in 1970s itself. So as per the recent study, it is also realized that in 2008, there were more devices that were interconnected than people today. Then let us see the industrial revolution as how it has evolved. Like if you look at IoT in a broader context, right, from the technology history, the first industrial revolution came up a couple of 100 years ago, which facilitated the production using water and steam power. Then the second industrial revolution was has introduced actually the mass production with the help of electric power, which you all know, and which was actually followed by the third industrial revolution, which we also call the digital revolution, in which electronics and IT further automated the production processes. So this is where IT and internet were actually introduced. And now, right, we are getting started with what we might call the fourth version of industry, or the industry 4.0, in which the digital and physical systems and also the things are combined for more even productivity. So if you look at here, right, more closely from the transition from third to fourth stages of industrial revolution, you can see that the internet straddles in both these areas. So with this, right, we can say that Internet of Things will be the main proponents for the fourth industrial revolution. So now if you look at as how internet has evolved, where we initially saw internet of content, which helped in the dissemination of content, where machine to machine were talking to each other. Later, the internet of people was introduced, where people to people were talking, and this is where social networking has gone to next level. So now we are seeing the Internet of Things, where everything is talking to everything, where like machine talks to a person or it talks to a process and so on, right? And also a bidirectional communication is possible today. And this we are calling it as Internet of Things. So just like how Internet of People have changed the world, The next phase of internet will be the Internet of Things, which will definitely change the world. So if you look at here, right, this is a nice representation of Internet of People, where people interact with each other using various social media platforms anytime, anywhere. Like few examples, you use Facebook, you use Twitter, you use Instagram, or you use LinkedIn for your professional network, right? These are the social platforms which are using day in and out for interacting between each of us, right? Next one is on the Internet of Things, where a variety of objects are controlled using a mobile device. Like for example, you can control the lights at your home using a mobile device, right? And of course, there are a lot of home automation services from various vendors which provide flexibility to control these devices from home remotely. Similarly, you are hearing more about the digital cars or connected cars. These are all coming. These are all right. They are categorized under the Internet of Things, are the connected objects as on today. So moving on to the related terminologies, so like Internet of Things can be synonymously used, or it is used synonymously by many tech giants, or also be it by many people today. It could be like, to state few examples, right? Intel initially called it as embedded internet. Later, GE has used the terminology of industrial internet. Even today, Cisco has been driving it as saying it as Internet of Everything. So in SAP, we call it as Industrial Internet of Things. So as on today, many telecommunications call Internet of Things as machine-to-machine communication. So all these terminologies which I was just explaining, right, they are used synonymously, but the concept and the concept remains still the one and the same for whatever the words they are using by different vendors or different IT giants today. So now let us try to understand the Internet of Things stack. Like IoT stack is based on multiple layers, and it is evolved with the convergence of operation technology and the information technology. So the bottom two layers, right, they are based on hardware, right? The nature of these layers is that it is in the data is in motion, it is event based, and also it is real time. So if you talk scientifically, sensors are nothing but transducers. Like in one form, they sense the environment and sense the signals, and in other form, they receive the signal to act and activate. So if you consider a simple example of a smart home, like sensors detect if there is no one in the room, then the actuators gets triggered to stop the heating system, right? So next one is on the connectivity layer, which is often referred to as the communication layer in Internet of Things. And it is a medium over which the data is actually securely transmitted to, or it is received from the IoT applications. So this connectivity layer again has some sub layers or the sub classifications, wherein it is further classified as a physical layer, wherein the Wi-Fi or the connectivity agents, right, the Ethernet or the Bluetooth will be handled here. Next one, we also have the network layer, wherein the address assignment like IPv6 or the Modbus, right, is taken care of the network layer. The final one is on the application layer. Like we have different protocols for communicating or transferring the data between the hardware and software, which is nothing but few examples are like HTTP, MQTT, or SNMP. There are several protocols which are used day in and out for our requirements today. Then the top three layers, right, are software based and are grouped as IT. So the nature of these layers is that the data is at rest, it is query based, and it is not a real time. So here, right, the application platform acts as a mediator between the physical devices and the IoT applications. So overall, right, this platform provides commonly used technical and business services to build an end-to-end IoT application in any environment. So to conclude, right, so in any environment, right, if you take any IoT application, you will see all this Internet of Things, that is Internet of Things stack, that is deployed. So now let us talk about the key enablers in Internet of Things. But before we talk about these scenarios, we should also understand that it's about the technical feasibility of Internet of Things. We should see rather than that, right, we should see more about the availability and affordability of hyperconnectivity and also the embedded technology, which sets the stage for Internet of Things. So now let us see the key enablers which made us talk more about Internet of Things over last few decades. So first one, right, if you see cheap and powerful sensors. So sensors cost, if you see, they have decreased by 10 times over last few years, right, in a few years, right. So in few countries, said people even say that integrated chips are much cheaper than the potato chips. So which itself states that the cost of the sensors has reduced drastically over last 1 decade. The next important aspect is on the processing power. So the processing power, if you see the devices what we had maybe around 8 to 9 years back, right, when compared to the devices or the sensors what we have today, it has increased a lot. So henceforth, right, the processing or transformation of the data, transferring the data from device to the database, right, it is very fast when compared to older devices. Then the size of the sensors is also one important aspect which we should definitely discuss. So by reducing the size of sensors, right, it has made it very easier for us to install and embed the sensors wherever it is required. So that is also one important thing which has helped to enable Internet of Things usage across the world today. The second one is on the cheap connectivity. So if you see, right, over past 10 years, the cost of bandwidth has reduced by 40 times. And as a result, right, a Wi-Fi is available almost everywhere and at affordable cost for everyone. Today, everyone has internet. Earlier, right, it is a costlier affair, like wherein to get internet of some Mbps or Gbps, right, we used to spend a lot of money, right? But it's not the case today. You get it at a very cheaper cost. So then the next one is on the unique addresses. Like with a growing number of connected devices, like it could be laptop or a mobile or iPad, etc. Right? We would need unique addresses, right? So with IPv4, we were able to cater only up to 4.3 billion addresses. But with the increasing number of devices, right, connected to this IP networks, we have moved to IPv6, which caters to about 340 trillion potential and new addresses. So this is providing the flexibility for us to connect like every atom on the planet today. Similarly, right, there are close to 6 billion smartphone subscriptions globally, and this count would reach by 8.5 to 9 billion by 2025, which a survey says. And in a way, right, the smartphones are becoming a personal gateway for Internet of Things today. So hence sending the data from one device to other, or for managing the data, we would need some data systems, or we would need some systems to store the data. That is where the concept of big data comes into picture. And this is actually used to persist and analyze the data. So if you see today, right, there are n number of vendors for big data systems, and one among them is definitely SAP or Google, or there are several vendors. So hence the availability rate of big data analytics will be one of the key enablers to handle huge volume and variety of data for us. Also, there are few predictions which analysts have derived, like where by 2025, there will be around 75 billion connected devices generating about 44 zettabyte of data, which is pretty big, right? And it is again contributing to around 11 trillion economical impact in US dollars, which is huge. So one point I want to highlight here is that Internet of Things is not about connecting devices, but it is more about the business value we are bringing in an entity, which transforms the business radically, and also the way we work. So with this, right, IoT is also helping us to improve the overall operational efficiency, and it is also helping to increase the overall end-to-end customer experience that we are offering as a service to the end users. So now let us talk a little bit on the end user segments, which is one very important thing which we should definitely understand in IoT terminology. So if you see, right, IoT is pursued differently by each individual. For some, it's as simple as a Fitbit device to track their health and wellness. For some of them, it's a smart factory. Or for some of them, it's a complex, it's as complex as remotely monitoring a hazardous working environment, such as oil rigs, for example. So if I have to classify Internet of Things based on IoT global market segments, right, there are two categories. One is on the customer facing, which has the consumer IoT. The second one is on the enterprise facing, which we have, where we have the commercial Internet of Things and the industrial Internet of Things. So the commercial consumer IoT is very simple. It's like a smartwatch where you wear, like for example, a Fitbit, right? They're the classic examples which are used for health and wellness, or for the step count tracking and so on. And in commercial IoT, right, if you talk about commercial IoT, it is applied to the commercial use cases. So let me take an example now. So for commercial IoT, so imagine that you are going on a long drive and you stopped at a fuel station. So as you refill the fuel, right, the fuel pump could connect with your car's dashboard system, and then the retailer offers you a discount on a drink or a snack or a car cleaner liquid, for example. Then how does this all happen? How is he able to offer this, right? It is based on the number of seat belts that are fastened in the car. So here car already know how many people are there in the car, and this information is actually transmitted to the retailer. Similarly, right, if you look at another scenario where your car has some issue, right, and based on the sensor from your cars, right, your car manufacturer, what he can do, he can actually predict the issue, what is the issue with the car, and then upfront he just gives us a heads up message and asks you to leave your car at the nearby service station. So this is where, right, the devices are talking to each other, and they are able to monitor, track, and provide the best customer experience to the end users here. So another simple example within the same use case is that the insurance provider, like where he can reduce the premium amount. Say, for example, I am not a good driver, right? And Pawan is a very great driver than me, and he drives better than me. So what it does is, based on the sensors that are installed in the car, right, it can actually track the driving patterns of the driver, and based on that, the end user or the insurance provider can realize like how well we are driving, and based on that he can offer the premium amount. He can give some discounts in the premium amount, right? So all this is possible, right? With the interconnected devices, where devices are speaking to each other or humans are speaking via the devices and so on. So to conclude, right, in all these scenarios, they are talking to each other, like which is called the commercial IoT. And of course, we are connecting assets, we are connecting the processes here in the scenario which I explained. And of course, the people are enabling the transformation of Internet of Things sensor data into the business outcome here. Ma'am, hope I am not going very fast. Am I clear?
Yes, sir.
Okay, ma'am. Thank you. So moving on to the next slide, let us see the participants in the IoT ecosystem. So there are several participants, right? And each participant plays a vital role in setting up the IoT stack, which we discussed just now. So first one, let me go through one by one quickly. So first one is on the product vendors, like they manufacture the sensors, they manufacture the devices, hard assets, right? Whatever is required for setting up the IoT platform, right? They manufacture all these devices and they provide it to whoever it is, for whoever they need to deploy the IoT application. So very good examples of the product vendors could be ABB, Siemens, Schneider Electric, GE, Google. There are many to state. Okay. Next one is on the service providers or the network providers. They take care of the machine-to-machine connectivity, or they act as the connectivity providers. Very good example here to state is AT&T or Cisco. Then comes the IoT platform companies. So they provide the device connectivity, ingestion pipeline, which we'll discuss in a while, and also any other services that are required to build the IoT application. Here again, SAP, Google, Amazon, there are many other vendors who provide these services. Next comes the system integrators. They are holistic, right? They provide the end-to-end service. They are the end-to-end service providers, where they bring together various sectors of Internet of Things applications and analytics in a pre-packaged solution. Good examples are like Microsoft, SAP, IBM, and so on. The last one is on the manager, sir. Hello?
Sir, please share your slide.
Hello?
Sir, please share slide.
Kindly share your PPT, sir. It's not visible.
Oh, is it? Yes, and sharing
Presentation
more.
is
Is it paused?
Sir, once again, you just share your presentation, sir.
Yeah, sure. I'm trying to share again.
Okay, sir.
So let me know, ma'am. You can see my screen.
Yes, sir. 1 second, sir.
Yes, sir.
Yes, sir. Now it's visible, sir. Participants, any one of you can confirm?
Yes, sir. Yes, ma'am.
Okay, thank you. So the one what I'm talking, is it clear to everyone, or you want me to do a quick recap on the ecosystem of participants? Okay, let me continue then. So the last one is on the managed service providers, like wherein they are the third party providers. Like if someone installs the IoT application in any environment, right, they take care of the round the clock monitoring or operation of smart solutions, or if any sensors has to be onboarded or deboarded, right, or decommissioned, right, or if there are any issues with the sensors, all this has to be done by someone, right? That is where the managed service providers comes into picture, and they take care of end-to-end monitoring here. Few examples could be TCS or Infosys or Wipro, where they are acting as a major managed service providers today. So this is the context actually I want to set as what is Internet of Things and how it is evolved over last few decades. Then to do a quick recap, right, later we try to understand the technology stack of Internet of Things, and we did see few examples based on the commercial and industrial Internet of Things, which is nothing but the enterprise IoT. So if you are still not very clear on what is Internet of Things, right, then let me put an attempt in a very casual way by comparing with human beings as an analogy. So if you see, right, all parts of human body are equipped with different sensors such as touch, sight, hear, smell, and taste, right? So IoT also starts with the same concept of sensing. So nowadays, right, machines are equipped with sensors which sense their environment, just like the 5 senses. Then there is a concept of communication and connectivity. Like the data coming from the sensors will be transmitted via the nervous system, that is to the brain, and the brain stores the data, that is a memory, wherein the data in the memory will be contextualized, analyzed, and that is helpful to derive the conclusions and also to predict on how to react towards the upcoming data streams, which is nothing but the mind power. So next one is the concept of control. Like for example, right, we are running, we see an obstacle in front of us, which makes our brain, right, to understand that there is an obstacle in front of us, and that is where it will trigger the actuator, which is nothing but our legs, to execute the jump. Similarly, assume that we fell down, for example, right? And we feel the pain. Then what does our brain do? It instructs us to go to a doctor. So in a similar way, right, like how the sensors in our body are working, right? A smart machine with embedded sensors would sense the vibrations and sense it to cloud, and the cloud would recognize the pain in the form of the failure patterns and the vibration data. And then it sends a technician, which by triggering a work order that will be created in the backend ERP system. So here, right, you can see the concept of things to data, data to insights, and insights to action that derives and defines the Internet of Things. So, well, like one important difference between Internet of Things and human beings is that, right, there will be, yeah,
Sir,
yes,
sir, I
ma'am.
think your slide is not changing.
No, no, ma'am, I did not go to next slide yet. I'm just trying to conclude with an example.
Okay.
I'll go to next
Okay.
slide.
Okay,
Okay.
fine.
So,
Thank you.
but with one difference between Internet of Things and human beings is that there will be far more sensors, right, than just 5 what we have with IoT devices. So there is one other aspect which differentiates the Internet of Things with human beings. Like our sensors like eyes, right, they do not have the local storage. We just see, right, but they don't have the storage, and they don't have the processing capability. But when you see the things, right, they have in IoT devices, they have their own smaller local brains with the capability to store, analyze, and also to react, right, to the data that is coming from the local sensors. So this phenomenon is called the edge computing or the smart edge, which we will take you through in next 1 hour. So now if you see here, there are a lot of components, and these are the components that are required for any enterprise IoT platform. If we see the component representation, which we discussed in IoT stack, right, which we just discussed also, right? So the first two components are like the sensor connectivity and the device connectivity, which fall under the operation technology, which we also call it as the hardware. The remaining components fall under the information technology, which is nothing but a software. Now let us see a little bit more in detail, right, about these components in upcoming slides. So if you see here, right, initially we have a device which is not at all equipped with sensors, and later it is turned out to be a smart sensor by smart device by equipping sensors to it. And final one is a representation of connected smart devices where they talk to each other bidirectionally also. Okay. So to understand the connectivity, let us look at this diagram of components of a typical sensor device, including the connectivity layers. So the device has sensors here. If you look at on the left-hand side, as we discussed in last section, then the sensors are programmed to send the signals to the device process. Then the device process will process the data, a raw signal or the data or the raw signal, and sends the processor data to the emitter. The device emitter will package the processor data as messages using some standard message types like JSON or XML, for example. Then the emitter will send the messages to the remote or the local system using some protocols like HTTP or MQTT by connecting them via the standard connectivity methods like Bluetooth, 4G, or any communication mode. So one important thing is on the MQTT. So it is a lightweight messaging protocol for sensors and mobile devices, which we are using day in and out for our setup today. So finally, right, what happens, the device also needs some security and configuration components. So if you see in the bottom right, that is where security and configuration are mentioned, which are used to enable the connectivity and security settings for the entire application. So the connectivity can be a cloud connected or it can be a locally connected. So let us see the cloud connected stuff. So if you see, right, a directly connected sensor can connect to the backend systems using high speed internet, and then it can send the data. So these type of sensors, right, they are completely based on Wi-Fi or 3G or 4G, and or it could be any other standard communication technologies. So for these sensors, right, a gateway is not at all required. And of course, the data can be stored in an on-premise one or a cloud environments as well. Next one is on the locally connected sensor. So if you see most of the time, right, sensor devices do not have the communication capabilities to transmit their sensor data in a secure and a reliable manner to the backend systems. So a locally connected sensor, right, it depends on the nearby gateways like smartphones or other means, right, or any other means to deliver the messages to backend systems. Then what does it like? These sensors, right, they use the Bluetooth or other communication technologies to interact with the backend systems, but with the help of the gateway layer. So what does the gateway layer do? Like it connects and receives the data from the locally connected sensors via the communication protocols like the low energy Bluetooth or the Zigbee. And at the same time, right, using these, the gateway also connects to the backend system, wherein using the high-speed internet, and it can send the sensor data, and it will be saved in the on-premise and the cloud environments, whichever we would need it. So this is a smart asset of an example of a smart cooler. Like as I already mentioned, right? Sensors in one form, they sense the signals. In other form, we receive the signals. So if you look at a smart cooler, right, like a Coca-Cola or any beverage cooler in a supermarket, they no longer are the shy devices, but they're equipped with sensors. They're equipped with actuators, and also they have the connectivity gateways which help to transmit some data like temperature, power, the the status of the door, how many times the door is opened in a day or in an hour, and so on, right? So by transmitting this data, what are we achieving, right? So we are achieving a lot of transparency. If I am a sales guy, I achieve a lot of transparency. Like I can understand how is the health of the device, at what time the device is accessed frequently, how many times the door is opened, or what is the temperature level at certain point of time. So these are the insights I definitely get, right? So with these insights from the sensors, it is helping me to improve the overall sales performance along with the operational efficiency. Okay. Then next one is on the device connectivity. So this layer is more like a glue between the hardware layer and the software layer, what you have seen earlier. So the main role of this device connectivity layer is the authentication. First one is on the device authentication. Say for example, in an IoT application, you have installed around 20 sensors. But if you see right in real time, there may be 25 sensors that try to authenticate here, which means there is a threat of hacking. Like 5 other sensors are trying to authenticate or transform the data into an environment, which should not be allowed. That is where the device authentication comes into picture, wherein that is handled at the device connectivity layer. And this authentications, right, there are several mechanisms that are available to ensure this authentication happens appropriately. One could be the certificate based authentication, it could be IDP based mechanisms, and so on. So now once the device authentication is done, it starts interacting with the software world, wherein it allows to send the data to the software world. So how does it happen? So that is where the protocols come into picture. So here, right, the communication layer transmits the data in different forms using the different protocols. So for the connectivity layer, right, as I mentioned, it sends a different layer, like different sensors are installed in the hardware world, and it sends different streams of data will be sent. And here, right, the connectivity layer will help to understand all the forms of data, and it has to transform to the software layer. That is a main role of one other main role of the connectivity layer. So another task of connectivity layer is managing the bulk devices. Like someone has to manage the sensors that are onboarded, or offboarding of devices, or decommissioning of devices, or issue fixing of the devices has to be taken care. So these all, right, I mean, in some applications there will be millions. So these all has to be managed by someone. This is where it is actually done in the connectivity layer. Similarly, right, we sometimes might have like age-old protocols in some connected systems, which are older systems, and we might be using very old protocols. Here, right, the device connectivity need to understand these protocols to transmit the data. So that is a role of connectivity layer here. So overall, right, to conclude, in the device connectivity, we are using the authentication is done here. We are using different protocols to transmit the data. Then the management of the sensors is done here. Then we are using the age-old protocols or the new protocols combined together. It's consolidating to send the messages to the software world. So next one is about the digital twin. So digital twin is a terminology which you have heard multiple times, right? So today manufacturing companies use machines, equipments, robots, or vehicles, or many other connected systems to run their production. So hence, to say in the broadest sense, right, an asset is a resource controlled by a company, while the financial information or the contractual information or any information related to the asset, right, it is, or the life cycle of the asset, right, is completely managed in the ERP system. So it could be also a depreciation or the maintenance contracts of the smart asset. Anything will be maintained in the ERP system. But if you see in a more digitized company, right, you can also have much more information about these assets, like the technical drawings of the asset, maintenance recommendations, what are the repair instructions, the health and environmental safety information. All this information can be saved in the ERP system. So what I would say is the digital representation of this physical asset is referred to as a digital twin, like which stores the identification or the operational or the technical and the status information about the asset over its entire life cycle. So to put in a crude way, maybe some of you may not like it, it's a metadata record in the database representing a physical asset, which with all the information which was just explained now. Okay. Then this is an example of a smart truck where we are representing the digital twin, right? So if you see here, right, on the left hand side, it is the the asset is tagged with sensors here, which is called a smart asset now. The information, right, the asset information or the contractual information, right, everything is stored on the left hand side in the connected system or the back end ERP system. And the asset is also equipped with sensors like the tire pressure sensor, right, or the temperature sensor, right, or what are the invoice details of the asset, right, what is the warranty information, right. All this information together, right, we call it as a digital twin, wherein the physical asset is completely equipped with all the contextual business context information in order to monitor or control the vehicle centrally. This is one example of digital twin with smart truck. So to recap, right, in step 1, we introduced what is smart asset along with its connectivity, and in step 2, we told how this hardware product can be connected to software using the device connectivity. Later in step 3, within the software, we talked about a digital twin, which is a kind of representation of your physical asset. Now imagine multiple devices are connected. So what's next? Sensor will send the data, right? For example, if you take a cooler, it has 4 sensors installed. It will be continuously sending data. Similarly, right, we have a trained customer which we work, wherein there are 1500 plus sensors which were installed, and there's a data inflow from the sensors which has to be handled using the ingestion pipeline. So the main purpose of data ingestion is to move the data coming from multiple sources to one place, like a big data store, for example. So in ingestion pipeline, again, we have 2 critical components. One is on industry-based message broker. Second one is on streaming. So here initially, right, the sensor data is passed to a message broker, which is currently a Kafka-based implementation. Then the message broker's main purpose, right, here is to make sure all the data is reliably buffered in the system, even when there are unusual spikes in the number of messages hitting the system from the devices, or if there are any follow-up components that are down, just in case. Now, let me take an example, a practical example to explain. So whenever a truck passes a tunnel, there might be a 15-minute delay in transmitting the data, for example. And once the truck goes out of this tunnel, right, when the data comes, that's where the data comes into the system. So here, right, we have some practical challenges, like someone has to push the data coming from the sensors so that it gets buffered on time for relaying it onto the follow-on components. So this will be actually taken care by message broker. So next one is on the message processing. Like Spark is one good example for message processing. So what Spark does is it allows us to distribute the calculations over a cluster of worker nodes, ensuring that a huge amount of data can be processed parallelly at the same time. So next one is on the validation of incoming data, which is extremely important. Like let us take an example of refrigerator. If a temperature sensor is sending, say for example, 50,000 value, this is all good. It is an integer value, but where is the from the semantic perspective, it is completely wrong. It cannot send 50,000 value, and it will be absurd, right? A temperature can be around 5 degrees, 6 degrees, or 10 degrees, and so on. So 50,000 value is an absurd, and definitely that need to be filtered out as a junk value, right? So one important point you have to note here is that these are actually not the rules, but we are only validating the authenticity of the data. Okay. So next one is a mapping. This is a data mapping, which also has some practical implementation problems. Like if I have a temperature sensor, then every time I will send the temperature values, right? But how do you understand it's a temperature or a torque, right? That is important, right? So the system has to understand, or we have to understand as an end user, whether it's a temperature or torque. Similarly, if I send values like temperature 5 or temperature 6, right? It consumes a lot of bandwidth if you send the entire word temperature 5, right? So that is where the data mapping should take care of. Like it will send T5, T6, and T7 values, and we should be able to understand that the values are temperature values. So the conversion of this data, right, from the human readable form is actually taken care by the ingestion pipeline. So apart from this, right, ingestion pipeline also need to take care of different types of sensors that are actually semantically aligned. Like you may have sophisticated sensors for mobile phone, right? But for the old industries, it might be different. So, but at the end, right, when the data comes to the software world, right, all this need to be maintained and persisted in the same way. Okay. So these are the few practical examples which we implemented over last few years, right? Okay. First one, if you take the fleet scenario, so it is sending around, for example, if you see here, right, it is sending about every 4 minutes, it's sending a message which is accumulating to around 7.5 lakh messages, right, which is huge. So this all information, right, by separating the junk values, it should consolidate and it should send the data to the next layers in the IoT stack. That is the main role of data ingestion. Similarly, if you take the example of train which I just explained. It is having 500 things connected, for example, and it is sending around 1 billion messages a day, right, which is huge, right? So this all will be handled by the ingestion pipeline. So now what's next? So data is coming from the ingestion pipeline, and you need to store the data somewhere. That is where the big data store comes into picture. So we have several types of data which are coming up from the sensors, and that will be stored in the big data store. So first one is on the raw series time series data. Is a continuous data, which we all know, like continuously the data will be coming from the sensors, and that will be stored in the big data. Next one is on the calculated time series data. Like let us take an example, right? If you have a fill level sensor which is fitted on top of a big container, for example, right? And if you want to calculate, right, what is a fill level, then what you do is you will calculate the distance but not the fill level here. So here what we have to do is we have to calculate the fill level with the dimensions of the object and also distance to the object. This is one example. Like the sensor will be on the top. For example, it is filled to up to some extent, and from there we'll calculate the distance using the dimensions of the object. Next one is the read sensor, right? So the read sensor, if you take for a cooler, right, it will only give the event of opening of the door, but not, but of course, right, it will only give the events, but we need to calculate how much time the door is open. Okay, so what we are doing in these both examples, right? So one has to actually derive the business data based on the naive data what we have. So just taking the data from the sensors will not help us. Then comes the aggregated data. So many times, right, the sensor will be sending huge volumes of data, and we don't need detailed data in some cases, right? Like for example, we might need only aggregated data, like what is the average temperature in the past 1 hour in the cooler, for example, right? That is where we use the aggregated data. So another way of consuming time series data is by segments. So a time series segment, right, is defined by a start and an end time that have a similar context. One example could be a drilling machine, wherein you take a machine, you drill some hole, that is one segment, and after some time you drill another 2 holes in a different place. That is a different segment, which we'll talk a little bit more on the segmentation next slide. Next is another example could be the trip start and the trip end times. Like during this time, right, if you want to monitor certain parameters of the truck, right, then we can go with the time series segment data. Okay. So for storing all this data, right, as I mentioned, right, we would need the big data store. So the data coming from different sensors will be stored over here. So we'll talk a little bit more on the segmentation with few examples in this slide. So segmentation, as I mentioned, is nothing but dividing the time series data into a sequence of discrete segments for revealing the underlying business properties. Now, if you see few examples on the big data segmentation, right, the first example is on the trip segment. Like let us assume like a vehicle is moving from the warehouse to the plant. Then we can define the trip by its vehicle speed or whether it has crossed the geofence or through any other predefined manual events. Like if you see, right, the trip one, if it is the starting time of the warehouse and it's reaching time, that is one segment. Again, it's unloading or loading there. Then again, the second trip is starting. So each one is represented as a segment here. Second one is on the replenishment cycle. So if you see here, it is representing the material volume levels at different segments. And each replenishment cycle here is represented by one segment if you look at the figure. The last one is on the usage segment, which we spoke in previous slide, right, where it is offered as a product as a service to the end user. In this case, right, we are charging the customer based on the number of holes that were made instead of paying the bill to the drilling machine. If you see, right, in the first segment, there is 1 hole, we pay for that. It's not about the entirety. If you keep the drilling machine, we pay for it. Then in the second segment, we have done 3 holes, which is charged again, and so on.
Suresh, I think the slide again looks like gone. Is it the same for everyone?
You want me to share again, Pawan? I am in big data segmentation, Pawan.
Yes, you share again, sir. It is got gone.
Yeah.
Okay.
Share again. Yeah.
Yeah, sure. Let me know, Pawan, if you can see my screen.
Yes. Perfect.
Yes, sir.
Okay.
Sir, it's visible, sir, your screen.
Okay, thank you.
Please go ahead, sir.
Okay, so now moving on to the next slide, it's more on the big data store. So to explain, right, various storage levels in big data store, let me take an example of how you organize clothes in your cupboard. So what you do, for example, you have a lot of clothes at home, right? So there are certain pair of clothes where you use frequently in a week, right? That you keep it in upfront in your cupboard, right in front of you, where you can access it very easily. Next one is on the, if there are some clothes which you use only once in a while, maybe once in a month or twice in a month, for example, if you use it, that is where you keep it some in the same, maybe you keep it in a different rack or a shelf in the same cupboard. But there might be clothes where you use on occasional purposes. Maybe for, like if you want to go some functions or for some marriages, you use it only for the occasional purpose. So similarly, right, how I was explaining the way you organize your clothes, right, the data is also organized in a similar fashion based on the usage frequency of the data in the data store. That is where the picture of the hot storage or the warm storage or cold storage comes into picture. So in hot storage, right, we actually access the data that is frequently used, which gives higher performance, but of course it incurs cost. Then the warm storage, which is less frequently used, right, that will be stored in the warm storage. Then comes the cold storage, wherein it's an archive data, like the data is older by more than 5 years. Only you need the data to be accessed only once in a while. That is where the cold storage comes into picture. Okay. Then you have the data that is stored in the big data store. Then what next? So next one is contextualizing. You have to contextualize the data what you have. So for example, if you have a temperature sensor fitted into a cooler and a micro oven, what happens in the cooler? It gives the how cold is the temperature in the cooler using a temperature sensor. For a micro oven, it gives it actually sends the values of the how hot is the food in the micro oven, right? So here the business context is actually varying. Similarly, right, if you have a sensor data of an asset without any information, right, like relating to an asset like product ID or which company it belongs to, then you will not get the business context, right? So that is where you have to combine the sensor data with the business context, the colored one, the second one with the business context like the product ID or the asset ID, in order to get the contextualized sensor data. So what I would say is the machine data should actually be blended with the business context in order to contextualize the entire data to have a meaningful insights at the end for the end users. So this is one good example of smart cooler. If you look at here, right, the first one, if you look at the cooler properties, it has a serial number, it has a temperature that is maintained, everything is mentioned. Similarly, the location properties, where is the cooler actually located, right? Or in which area code is a sensor, is a cooler located. Third one is on the business properties. Who is the area manager for it? Who is the sales representative? What is the customer service in case of a repair? For example, right, you have a cooler installed at Andhra University. You have some issue with your cooler, for example. Then what you do immediately, what you'll do, you'll try to contact. If you have a good contact of the area manager, you try to call to them, you address the issue. Or you call to the customer service directly and you report an issue. Then what will do, the customer service agent will have all this information related to cooler, like what is the location ID, what is the make of the cooler, what in which year, whether it is in warranty or not, all this you'll be able to check. He will try to fix the issue remotely. If he cannot fix the issue, then what he does, he tries to create a service request. Then the service provider will access all your cooler information. You'll try to understand, you'll come to your location, fix the data. So all this, right, he is able to do because we have some business context. If it is only having the sensor data, right, the ERP system is only having sensor data, right, then we cannot address this, right? So that is where we have to combine the sensor data with the business context in order to make the cooler work centrally or monitor the cooler centrally. Similarly, right, let us take an example of smart silo. So a silo is a big container sort of, right, where we can store huge volumes of grains or cement or any types of animal feed, right? So then it might have several sensors installed, like the fill level, which I explained, or the temperature sensor, or the pressure or humidity sensors, and so on. And we also need to understand where is a silo located based on longitude or latitude or the postal address and so on. And as I mentioned in the previous example, right, if there is something wrong, the temperature sensor is not working, some service request has to be triggered, right? That all will be stored in the central system or in the big data store, wherein it is giving a big, if you see right here, we are combining the sensor data along with the business data or the business context data, that is a master data, in order to control the smart silo centrally here. So next one is on the consumption. So now we have the data. So we have contextualized the data. So now we have to analyze the data for anomalies or deviations. And based on these, right, anomalies, right, we can trigger actions, wherein this data will be fed into the system for further deriving analytics or meaningful insights there. So there are two here. First is like you have to contextualize data. If there is an anomaly or a deviation, right, we have to trigger some actions, right? That is where it is done by the rules what we define. Next one is on the applications or the analytics, where we can see the current insights based on the history data, or we can predict the data, or we can do some machine learning, how will be the sales in upcoming months or years, for example. So for defining the rules, right, we have a rules engine in Internet of Things. So if you typically take, right, any rules engine in IoT, it looks like three layers as it is represented here. The first one, right, the data is coming from the sensor continuously, like temperature is greater than 20 degrees when the vehicle is transit. Like if there is a requirement wherein if you are sending certain food on the or certain packets in the vehicle, right, the temperature should always be 20 degrees is maintained by the end user. Then what happens? It will be continuously sending the data. That is the rule we define. Second one is on the batch rules or rules on the persisted data. So where you are not interested on the incoming sensor data, but you're interested on the aggregate data, which means I want to know what is the average temperature in past 1 hour, for example, right? If the milk is stored in the refrigerator, then what is the permissible temperature maintained? Or if it is a beer, right, what is the permissible temperature maintained over last 1 hour? So all this type of data, right, is called rules on persisted data or the master data. So next one, right, it's not any, it's a mute layer, like it's not sending any data. For example, the sensors are not working, or it is sending some junk values, like temperature example, which I gave you, it be sending 50,000, right? It's a mute layer, right? So it doesn't send any data or it sends junk values. So what we are doing based on these rules, right, we are trying to identify the anomalies, and then we are trying to trigger events, which will lead to actions finally. So while defining the rules, right, there are few aspects that need to be taken into consideration in the world of Internet of Things, which is extremely important, right? So in one of the projects, right, we implemented sensors with temperature greater than 5 degrees for 3000 coolers. So within a day, these are initial projects which we worked. So within a day, right, we got 75K plus alerts, which have actually spammed our mailboxes. So the main reason here, right, the cooler on a certain day, the sales of the drinks in the cooler, right, is extremely well. And the cooler is opened by customers several times, right? So then what happens, the temperature is what is happening is it's going more than 5 degrees up to certain time, maybe for 1 hour. And then again, it is coming back to 5 degrees. So this is not an issue, right? Then the alert should not be triggered. So we need to handle the rules engine very intelligently. Say, for example, if the cooler is used frequently, there might be a deviation of temperature increasing from 5 degrees to 6 degrees or 7 degrees up to some amount of time. So the rules engine should validate all these cases based on the way we define, and then only it should trigger some events or alerts to the end user. Similarly, right, if you take an example of dairy, like a representation what we have given here, where they maintain huge volume of milk in big containers, right? And it is obvious that the fill level will reduce by midday as the milk will be delivered to the customers. But here, right, we should note that the event should not be triggered immediately if it goes below the threshold, because at times, right, there might be a delay in filling the milk tank due to some external factors which you might be already aware of. Right? Hence, the rules, right, need to be paused until the next event occurrence to validate the fill level, and then only trigger the event if required. Similarly, if you look at the second instance on the right hand side, there might be some ongoing repair work for next 3 hours. And if you're already aware of this, right, then the rules engine can be paused for a certain period of time. Right? So here the rules are actually defined intelligently so that the events are not triggered for the for the things which are not actually required. Here, right, we have to pause the rules to ensure that the junk mails are not, or junk events are not triggered here. So there are a few other examples which we figured out, like the geofence rules, right? If you look at here, right, the truck enters into the relevant geofence, then based on the relevance, right, it will trigger an event. So for example, it is out of the location, right? Then the truck is within the geofence. So we can trigger based on these events. That is also possible using the geofence based rules. Next example, right, if you see, right, there is a warehouse and a plant. What is happening? The truck is starting from the warehouse, then it is moving to the plant with a load, then it's unloading there and it's going back. So during this time, right, what we can do is we can derive the data from the sensors, like what is the loading time, what is the unloading time, when did the truck move out of the warehouse, when did it enter the plant, and when did it come back. So all this can be controlled by the geofence based tools. The third one is on the cooler example. So for example, a cooler will be kept in a designated place, right? It cannot be moved wherever we like, right, every time. So if the cooler, for example, is moved within the same building, right, then it is fine. But if the cooler is moved outside the building, that is where is coming up the theft detection. So the rules, whatever we define, right, will help for the theft detection in the case of a cooler movement within the building or outside the building, for example. So now we have some anomalies detected. We have triggered some events, right? So the rules engine has done its job in raising the events like what is gone wrong. So what's next now? So we have to trigger action, right? So we can trigger email notifications, or we can send an SMS to our mobile numbers, or we can trigger actions, right? Based on the device information, or decision support, right? We can also decide some workflows can be triggered from the system, or the system itself. We can write some programs or code, right? Wherein the decision can take a decision can be taken by the system itself based on certain actions that come up or certain anomalies that come up in the system. So these are all possible through the actions by triggering to the few things which I'm just showing in the slide. Now the contextualized sensor data can be fed into applications and also to the analytics. Like there are different types of analytics. Like it could be the raw time series chart or the operational chart or the physical based models. It could be anything, right? This has to be fed into applications and also to the analytics for better visualization in order to take better decision users, right? Better decision making by the end users. So this is an example of a coffee company where thousands of coffee machines were installed in public and private places, right? Here the company would like to have some insight on the device status and usage. Hence, they worked with the vendors to install all the IoT components, starting with the device layer by installing sensors in the coffee machines, connecting the backing systems, and also finally analyzing the data in a packaged IoT application. So the visualization, the slide, right? If you look at on the left-hand side, it provides a nice insights, right? Wherein the real-time working status of the coffee machine or the master data of machine, how much time the machine is actually switched on, what is the fill level of the coffee ingredients in the machine is shown here. On the right-hand side, right, it is actually giving the trends, right, of coffee consumption, like usage insights, what is the stock level or the inventory insights, or what is the brew temperature, or what are the quality insights, right? Overall, it is giving. So this is so all this data. How is it possible? We are actually combining the sensor data that is coming from the uh, sensors along with the business contextual data, like business data or the master data, whatever we have in the ERP system, to uh, to have better insights or meaningful insights to take on next decisions. So similarly, these are the analytics, right? IoT application analytics features that they provide they are providing coffee company deeper insights. So for example, right, users can analyze the top 5 coffee brands by region and notice that if you notice here, right, the brand Manhattan Special is very popular brand, especially in East region. Similarly, the brand Costa Coffee is doing well in South region. If you look at the end, right, these are all the analytics. As I mentioned, right, to a recap, right, from the sensor data, we are trying to gain some business insights, and we are also giving some reporting now. If you take that, these are the few examples, right, how the sensor data is transformed to business insights and then to reporting. Like if you take the door openings, for example, right, we can derive the sales performance and return on investment of cooler based on the aggregated number of door openings in the store. Then the store based on the where the store, where the cooler is present in the store, and then based on the marketing campaigns, right, we can also derive like this particular time we did a marketing campaign, and that is where the door openings have increased, and that is where the sales has actually improved overall, right? This type of analytics or insights can be derived based on the reporting needs what we just discussed. Next one, for example, if you talk about the power status, if you take power status of a cooler, right, we have to check if the contractual agreement is breached or not, but not about how many times the power is gone actually. Similarly, we can check based on the compliance, like where is my cooler existing? Is it in a right location or a different location, right? That is also one important aspect which we can consider. So when we are getting the sensor data, right, we have to combine it with the master data, whatever we have in the ERP systems, to in order to better business insights and for reporting.
Sir, we request all the participants to please mute their microphone, like we have a little disturbance.
Yeah.
Sir, you can please continue.
Yeah, sure. Thank you. Yeah. So next one is on the applications. Like these are the applications we have based on enterprise IoT, right? So we have smart cities, we have connected cars, or many. These are the examples which I'm just showing here, or connected logistics. All these, right, applications are built on the Internet of Things stack, which we just discussed, or the components, right, which we discussed all now, right? All these components are required in order to build these connected applications in today's world. Okay. So now this is the overall components which we discussed over last 45 minutes, right? So now I will leave it to Pawan to do a quick recap and then proceed with edge computing and business examples now.
Yep,
Thank
sure.
you so much, sir. Sorry, sir. Thank you so much, Dr. Suresh sir. I now request PV and Pawan Kumar sir to please go ahead.
Yep, sure. Let me know if you can see my screen. Yeah?
Yes. Yes, sir. Your slides are visible, sir.
Okay. Is it all good, Suresh?
Yes, yes, Pawan.
Yep,
Please go
perfect. Thank you. And thank you, Suresh, for setting up the stage by introducing what is IoT and then the technology ingredients that form IoT, right? So let me quickly recap what Suresh explained over here. You take any IoT use case in this world, be it your Fitbit use case, where in your mobile app you can see the calorie or calorie burn and all that, or be it a refrigerator use case where you can see something else, or an aeroplane use case, or any use case. In any use case, these technology ingredients are going to be common. Okay, the first one is your actual physical asset embedded with sensors. Okay, and then that is your hardware. Now that hardware needs to be glued with the software, right? That is what will be done by your device connectivity, this particular piece. Okay, this particular piece of is going to glue together the hardware and the software. And on the software side, in case if your asset is a refrigerator, or if your asset is a machine, any other machine in a production environment, that needs to be understood well. That is represented by your digital twin. Okay, then we are talking about millions of devices getting connected, and data is coming from the sensors, right? I mean, a lot of data is coming from the sensors. So ingestion pipeline is like your water pipe coming from a big water source and supplying to different houses, right? It is like a big pipe which will take all the data through that pipe and get it stored in the big data store. Like Suresh already explained, the data can be stored in tiered way, like a hot store, warm store, cold store, like the way you kind of store your clothes at your home. Okay, and then we add little color to the data, that we call it as a contextualization of the data. Like if a temperature sensor is sending the value as 10, we don't know whether it is high or low unless we know if the sensor is fitted to a microwave or a refrigerator or a washing machine, right? So that context will be provided. That is what I call it as adding color to your sensor data. Now your data has flown from the devices to your software platform, got stored and got added color. Then it needs to be consumed. Now you have all the data. You need to find some mistakes or anomalies or some patterns, right? So the mistakes, anomalies will be found by your rules engine. If this happens, do this. If that happens, do this, kind of a way. Then if you want to analyze the sensor data, that is where you will do analytics and you do ML prediction and all that. Yeah. So this is an end-to-end technology ingredients that will be there for any IoT use case. Now let's understand what is edge computing. You must be hearing edge computing a lot many times, right? And some of you must be knowing for sure, and some of you maybe it is new to you. So let me give some quick insights into what is edge computing. In a typical IoT cloud computing, right? What happens? Let's imagine a refrigerator at your home, and it has got a sensor, temperature sensor. Okay, and this particular sensor will be fitted to a box, right? Some black box which will have the SIM or Wi-Fi connected and all. That box is going to directly send the data to cloud for processing. And this cloud is a data center, correct? A cloud is something like a data center somewhere in Mumbai, and your home is in Visakhapatnam. So data is going all the way via Wi-Fi or a SIM, okay, to the cloud in the data in the Mumbai, and the calculations are happening over there. Like if the rule is something like if temperature in the refrigerator is greater than 5, send an alert message. Or if the average temperature in the past 2 days is greater than 15, then create a repair request in order to repair the refrigerator. So this processing is happening here, and the data is all gone all the way to the Mumbai data center, right? It's an example. Now that is what is IoT cloud computing. Now what is edge computing? Edge computing describes the capability of processing, storing, and analyzing the sensor data at the device itself, at the edge node itself. Okay, why do we need to do so? Right? Sometimes sending the data all the way to the cloud is expensive. For example, imagine video camera. I mean, this is an use case where we really discussed with one of the customers. You must be seeing windmills, right, outside of the cities. And the biggest problem over there is the animals, or dogs and other things comes to the area of windmills and they spoil. So basically, they don't want that to happen. They install a video camera. Now the video keep on capture if someone is entering the area. If someone enters, it raises an alert to the person to to clear the situation. Now, how many times such situation happens? Maybe twice in a month or thrice in a month. Further, do you want to send all the video data to the cloud? This is going to be expensive, right? You are sending some data, like you are sending a big parcel from Visakhapatnam to Mumbai. It's expensive, obviously, correct? So the data transmission is expensive is one reason. The second reason is a real-time decision making. Sometimes you need to do real-time decision making on that device itself. For example, in a mining situation, the mining blade goes all the way like this in the mining. Okay. Now, if you send all the way the data to the clouds, and the cloud is situated somewhere in the Mumbai or Delhi or Singapore, Vietnam, the data that returns back, the action return backs may take few seconds of time, right? And you can't afford that. Sometimes if you get delayed, maybe the mining blade is going to cut the hurt the person over there. So there are a lot of industry use cases where you can't send the data all the way and wait for its response. Okay, you need to process that locally itself because you can't wait. And one practical problem I faced when we were showcasing a smart vending machine to Bill Clinton, who is a former US president, right? What happened was there is a vending machine. He swiped his card, and then he wanted to buy a Coca-Cola bottle, but it took around 5 minutes to get the bottle of the payment is done, because the processing has to happen all the way in the data center somewhere else. And because of the network bandwidth issues, like when we watch movie, it keep on load, right? I mean, it kept on loading, and the Coca-Cola bottle never came for 5 minutes, and the guy left from there. But this is a normal situation. Imagine in mining or other situations where it is going tricky. Third one is intermittent connectivity. If you take scenarios like ocean, if you go to middle of a sea, you will not have a signal. Or if you go to some places, you will not have signal, especially in the hospitals. In certain areas, the signals are blocked. In such situations, if you wanted to do some sort of processing, you need edge computing. Now, what is an edge device? Typically, this is also something which comes up. An edge device is something like a ship in an ocean, or an oil rig which drills the oil from the ocean, or a retail store. Your DMart can be an edge device, or your tank in the war, right? Or any equipment in a manufacturing production system, or a crane. Any of these things are called as an edge location. Technically, these edge locations are nothing but the IoT gateways. Okay, we call it as IoT gateways. There could be PCs and all this. Fundamentally, these edge locations will have some storage, some power, some processing power to do processing there and there itself. Now, if I need to go back again to compare the IoT cloud computing with edge computing, we have seen this cloud computing per se, right? The fridge is located in Visakhapatnam, and then the data is sent all the way to Mumbai for evaluating these two rules. Whereas in edge computing per se, one of the rule will be evaluated at the fridge itself. And another complex rule, you wanted to do it in the cloud. This we call it as a edge computing overall. It is something to, if I take an analogy, it is something to do like your subconscious mind and conscious mind. So a most routine and regular task that you do via your subconscious mind, where you don't need to use your mind power for too much of thinking, right? You just do it. Okay, that we call it as a edge computing. Whereas for certain tasks which you need your superior brain power, we send all the data all the way to your conscious mind for the further processing. That we call it as a cloud computing. Yeah. Now let's look at use cases, how IoT has been used across different industries. If I want to sell IoT as a technology, no one will buy, right? It has to make some adoption. It has to be embedded into one of the existing processes. That is when IoT is very well received. I'll give an example how it works. Yeah. So there is a company, this is also a real life example. There is a company which produces artificial flavors. You know, artificial flavors, something like a mango flavor, strawberry flavor, what we eat in strawberry flavored ice cream. That flavor is an artificial flavor, right? So this company produces artificial flavor. So definitely while producing, they need certain raw materials like sugar, right? And these raw materials are put in a very big silos. Okay, then what they do, they kind of process this sugar with fruit ingredients, like here in this case strawberry, and produce strawberry flavor. And this strawberry flavor, what they do is they put it into small containers or a container tank truck, and then they send it to their customers. Now what their customers do is they further process this strawberry flavor by mixing with the soda and make a strawberry drink, or by mix with the curd and they make a strawberry flavor curd, and then they put it in a retail store for selling. So this is a standard process for them globally. They send these flavors all the way across different countries to the globe. Okay, now the biggest problem for them is the following, right? When they send they have the biggest problem is, how can I ensure that the sugar is always maintained in the silos so that I will never stop my production? Simple, right? I mean, I need sugar in order to produce this artificial flavor, but if sugar is out of stock, automatically if something triggers and then sugar gets replenishment without any further delay, I mean, that is a good case, right? So replenishment, they want to ensure, they want to monitor the fill level of the sugar in the silo, and based on the consumption rate. For example, your IoT rule says that you are left with 10% of the sugar in the silo. Then the last 10% may take 10 minutes, 10 hours, 10 days, right? You calculate the consumption rate. You also know who is the lead supplier. This company may have 2 to 3 different suppliers who supplies the sugar. Who is the supplier who takes the lead time or less time, who can supply the sugar before the current sugar quantity gets out of stock, and create a request, a replenishment request to that particular vendor. This is all what they want via IoT. Okay. And next, when they send the strawberry jam via containers, again, they want to ensure whenever their customers are consuming more and quickly, they want to ensure they send quickly again back, again, new sets of containers with the flavor, so that, they can do much business. That's one thing. The other use case they wanted to do is, most of the times when they send these containers, right, they get lost. So they wanted to do track and trace and identify the unauthorized movement of these containers. And finally, this is one of the best thing, right? I mean, if you take any edible, you will see an expiry date, right? The expiry date is based on the manufacturing date, correct? Okay, 6 months from the date of manufacture, they say. But what happens if you don't maintain certain things at the right storage conditions? They will spoil and they'll become toxic as well sometimes. So the expiry date is invalid, frankly speaking. If you take milk as an example, if you don't keep it in certain temperature or in a refrigerator, if you keep outside, you have to consume so quickly, correct? In a similar way, these artificial flavors, or even it is very much valid to medicines also. They have to be maintained at right temperature and or right storage conditions, right? If that happens, dynamically adjust the expiry date based on the storage condition. This is what they wanted to do. What does it mean? If they send a strawberry flavor to a customer, and during the transit, because they send to different countries and it takes a lot of time, right? During the transit, if it is not maintained well, you tell the customer upfront that, hey, even though the expiry date is the 5th of October, because of the storage conditions, it will expire by 2nd of October. Ensure you use before that. Okay, this is what the use case. And these are the containers I am referring to in that particular customer example. These are the 500 liter or 1000 liter container they send across the globe. Okay. In one of the chemical company, pharma company, what they did is they were sending the medicine, the liquid medicine in such containers to different countries. And the use case is again the same, whether it is a fruit jam or it is a milk or a beer or a wine or a medicine, it's the concept is same, right? Yeah. Now, what they were doing is they have in their warehouse, these containers are all there. Okay. And they send all the data to their local gateway. Okay. And the local gateway will send the data to the IoT application. When the containers are loaded to truck, and the truck will have again the gateways and the mobile gateways, and they send the data to the mobile gateway, and this mobile gateway will send the data to IoT application. When it reaches the end customer also, that's exactly happened. So across the ecosystem, there are gateways which picks up the sensor data coming from these containers, and then, relay to the IoT application, and IoT applications does the processing. Okay. So in this way, you can embed IoT into any use case that you want. In this case, I have taken the example of replenishment. I'll run through some of the practical examples what were implemented. Okay. So before getting into it, let me quickly review the overall architectural view of IoT, or I would not say technical architecture, rather functional architecture. So your IoT platform, what Suresh explained, is all this, right? All this. Now this IoT platform that has a lot of technical components and all. Now every device can send directly data to IoT platform, or they can send data via edge computing module, or they can send data via OPCU. In manufacturing, OPCU is one of the standard protocol via which data will be sent. Okay, all the data will be sent to the IoT platform. On other hand, you get the business data from the business systems. Like for example, if I take an example of your attendance, right? Let's imagine you have ID card, and ID card is scanned at the entry of your university. Okay, when you swipe it, it opens the door for you, and you're going to get in. That is what your sensor part, right? Now that ID card will have an ID number which relates to some ex-employee within the university, right? Or ex-professor or a student within the university. That information comes from your business system. That won't be stored in your IoT sensor. That will be coming from the business system, right? So such kind of information, you get it to the IoT platform, you blend it, you get the sensor data and you get the business data, you blend it together. Then what happens is you supply that to the IoT use case finally. It could be street light monitoring, it could be cold chain monitoring, or a smart city, smart factory, whatever the use case, you supply that. Or you give this data to analyst who will do further analytics, like what Suresh showed for a coffee machine example. Or you give to a data scientist who can do machine learning and derive some model, a machine learning model, and then use it across for further analysis. Yeah. So this is how the overall enterprise IoT landscape would look alike. Yeah. Now, how companies use the IoT across the different businesses? Firstly, IoT is being used for improving efficiency. I will run through some of the examples. Okay. Then IoT is being used for improving customer experience. And then IoT is being used for getting new revenue models, new revenue streams. And finally, IoT is used when there is no connectivity or intermittent connectivity issues, or you wanted to process the data and the edge location in such kind of a situations. Okay, for each of these categories, I will run through some of the example real life implementations. Okay, the very first thing what any company want to do use IoT is for improving the efficiency. It is as simple as, you know, there is a port in Europe, which is one of the largest port in the Europe, which handles approximately 10,000 ships and 9 million containers every year. Okay. Now what happens is they are anticipating that by 2025, 25 million containers that port has to handle. It is as simple as Visakhapatnam railway station has to handle double that number of trains within the same platform, within the same railway station. They don't want to increase the railway station, but they wanted to make the station more efficient in such a way that they should handle the more train traffic. Now what we need to do? Then we need to make the overall process connected and efficient, right? In this case, what they did is they kind of embedded sensors into the traffic signals, parking lots, and many other things in such a way that if any ship arrives with containers, as you see in the picture, right? They arrive with containers. The big truck will come to the port and collect those containers and go back. Imagine the ship is getting delayed. Now this big truck will go all the way and create traffic problem and wait at the port, right? So that is a big problem. Not just one truck, multiple trucks go there. So when you have the real-time data coming from the sensors, where is the ship, where is the truck, how is the traffic, and traffic light signal is also connected, everything is connected. What happens is you can efficiently manage when the ship is arriving based on the time the truck can take to reach the port will be properly scheduled dynamically on a real-time basis. Like if your friend says, oh, I'm getting delayed by half an hour, you will start half an hour late. Simple, right? You plan to meet at certain point, and your friend says, I'm half an hour late, and you will go half an hour. In a similar way, right? When all these objects talk together in a transparent way, you can efficiently manage the traffic. That is what this particular use case is all about. Yeah. And the next use case is about RO treatment plant. Okay. And we all know what is an RO. I no need to explain. RO is the process of water purification, which involves forcing of water through semi-permeable membrane. Okay, so that you can filter out a lot of elements like arsenic, nitrates, etc. and etc. Okay, now what happens with the ROs is they get foiled. If I take an example of a 7 MLD RO desalination plant, they will have so many membranes for the filter process. They will have 3 RO streams, and each stream will have 30 pressure vessels, and each pressure vessel will have 8 membranes. Then you can imagine 3 into 30 into 8, that many membranes will be there. Now the biggest problem for them is they don't know which membrane out of all these will get foiled. Company don't know. It's very difficult to figure out. And also when they stop the processing, it will affect the downstream processes. RO plants are not only used for drinking waters in the industry. They're also used for the, so many processing. For example, power plants need RO water. And then cement processing needs RO water. Your beverage drinks kind of things needs RO water. So if water itself is not there, your production will get stopped. And what companies realize is they lose few lakhs and lakhs of money every few months just because they need to shut down the plant to replace the RO membrane. And they don't even know which membrane is foiled also. They must be having some thousands of membrane in the plant, but they just generally replace every membrane at a certain period of time. Now, this is what the challenge they face. Now, what they did is, again, they kind of inserted a lot of sensors. If I take an example of this particular RO plant with, 7 MLD, they inserted 25,000 sensors across the plant, which produces 3 million data points every day. Okay, and this data gets stored, that is almost equivalent to your 30 GB of data. And this data is analyzed, and 22 key parameters are are figured out based on the 63 algorithms. Now you can see these sensors provide lots of data like conductivity, pH value, etc., pressure, and all those things. Based on that, 22 key water parameters are calculated. Based on that, the company were able to understand which particular membrane is going to get foiled upfront. They are trying to predict when the membrane will get foiled and go and replace that particular membrane even before it gets foiled. Not the entire plant, only that particular membrane. So in that way, they were able to save lakhs and lakhs of rupees every time. Yeah, this is one example. I'll take another example. This is one classic example where we have with beverage companies like Coca-Cola, Red Bull, Pepsi, or all these companies have beverage coolers, right, or beer companies. If you go to any supermarket, you will see a cooler like this with their own drinks, correct? Now, the biggest problem for them is what they do is they will have millions of coolers and they give retailers for free. Okay, if I am the operations manager of this particular beverage company, if I give 1,000 coolers in Visakhapatnam, it is my responsibility to ensure to make some business out of it. It is my responsibility to ensure whether I gave coolers to the right set of retail stores. My responsibility to understand when a cooler is not working to get it repaired, right? Now, the biggest problem for them is, first of all, once they go out of their premises from their warehouse to the other locations, they don't know what is happening with them. Okay, and they don't know sometimes where they are also. Many times retailers take these coolers and they keep it in the home. Okay, and also they misuse as well. Sometimes they use it. For example, if mine is a beverage drink, I gave it to you to keep it in your retail store. And you can always see coriander or many other curd, cheese, and all, put it in the same cooler. I gave it for free to sell my drinks, not to sell coriander, right? So this is a practical problem for them. Another problem is if they keep coriander, curd, and all, this is all fine. If they keep competitive drink, that is a further damage to that, right? And I'm giving cooler to sell my drink, and you are selling my competitor drink, right? So these are the kind of issues they face. If a cooler is not working, we surveyed with some of the companies and we figured out that it takes 15 days to 20 days to get it fixed. Now, if you go to buy a Coca-Cola or any drink, any cool drink, if a cooler is not working and if it is maintained at 30 degrees, will you buy the drink? No, you will go back, right? Or you pick up a competitive drink from other cooler, right? So this is what the biggest problem for this particular company, and they are losing millions of dollars of money every year. And now the IoT use cases are location monitoring. How can I ensure that I gave to a cooler to a particular XYZ Kirana store? Is this Kirana store is still keeping the cooler at the right place or not? So that kind of a location monitoring is being achieved with IoT. And you have seen how it is achieved via geofencing kind of a technology Suresh explained. And then operations monitoring based on the real-time data coming from the cooler. Okay, this company will know whether the cooler is been working rightly or not. In the past 2 days, the cooler temperature is 25 degrees. Oh, there is a problem. Let me send a technician upfront before the guy from the shop calls and say, hey, there is a problem. Okay. The third one is to monitor the usage of the cooler. Okay, I gave cooler to all the areas in the Visakhapatnam, but I see the east part of the area is not no much sales are happening. So is that a right way? How do they figure out the sales? Based on the number of the times the door is being opened. If the door open is 10,000 times in a month in all other locations, and whereas in the east location it is only 100 times, then you know dynamically on a real-time basis why which area the cooler sales are not happening. I mean, the beverage sales are not happening via cooler. They kind of rethink about their marketing strategy, right? So these kind of real-time insights they get. And what sensor did they insert? They kind of put temperature sensor, power sensor, door open sensor, and all other sensors, yeah, location and everything, yeah. Let me take another example. This is a smart city use case. This has been implemented in city of Heidelberg, okay, in Germany. Heidelberg is a city in Germany, which is a very nice city, nice looking city, yeah. So the use case over there is they have a lot of trash bins, dustbins. So whenever the dustbin is full, they want to ensure the right truck goes nearby that and empty it. Okay, so that the area won't be over flooded with a lot of trash, and also they want to ensure unreasonable trips for the truck as well. Typically, what happens? Every truck which picks up this dust will have certain schedule. As per schedule, they go to X, Y, Z locations and they pick up the trash and they go back. And many a times these trash bins may not be full and they simply go there and come back. It's a waste of trip, right? And also waste of fuel and everything. At the same time, if a trash bin is over full and it is not good for city, right? So on a real-time basis, based on the fill level sensor that is being fitted over there, it will tell what is the trash level, and based on that, they kind of send these particular trucks to empty the trash bin. Yeah.
Sir,
Yep.
kindly excuse me.
Yep.
Dr. Vijay Kumar garu. Sir,
Hello.
Dr. Vijay Kumar. Sir, I think I'm very sorry. You please go ahead, sir.
Okay, fine, yeah, sure. Okay, now in this particular case, what happens is that the trash will be put into the trash bin, and via LoRaWAN network, they send it to the cloud for processing, and your IoT application will know which trash bin in the city is getting full frequently and which vehicle needs to be sent to empty it. This is a kind of use case that have been implemented. Okay. So I'll skip this solar farm monitoring. I mean, given the time, okay. And then, like that, the IoT has been implemented in the retail world as well for inventory. Like for example, smart shelves. As and when you pick up certain product from the retail store, when it is scanned, based on that, automatically you create a request to the supplier to supply that particular stock. So you picked up a Colgate paste. So then there is a stock has been reduced, right? And based on the demand, automatically you create an order. That kind of a replenishment automation can be done with the IoTs. Okay, and also the smart routing. As I mentioned, if a vehicle is going to refill Coca-Cola in certain retail store, on the way they figured out that there is a stadium where a cricket match is going on and the Coca-Cola is out of stock there, and this particular truck has got surplus amount of Coca-Cola bottles. This guy will reroute there and automatically go there. As per the plan, this truck has to go to store X, but based on the real-time insights coming from the sensors and all the machines, stores and vehicles are talking to each other, they go to other location and refill it. Okay, this is a kind of an example, smart routing. So at the end, what I mean to say is, it could be the tracking of assets themselves, asset monitoring, like your refrigerator monitoring or a container monitoring and all that, or a product within an asset, right? If the container is taking milk or medicine or XYZ, any other particular material, monitoring the material. In both the cases, it is all about the monitoring of an asset and monitoring of the material or a product within the asset. These kind of use cases are quite popular, and I mean, when you connect all the devices together, you can improve efficiency in the IoT world. Yeah. Now, the next set of use cases is IoT is being used for superior customer experience. I'll give an example. Yeah. So imagine that you are a manufacturer of a heating or a cooling or ventilating machines. What your customers rely on is the uptime and the availability of your machines, the quality and the quality of the product the machine produces, and service you provide in case if machine goes for a issue, right? That is what you wanted to do. Imagine you have this battery, inverter battery at your home, and if it has a problem, what will you do? You will pick up your phone and call the service technician, and service technician comes all the way to this location, and we will search whether what problem is with the battery, and then go back again to get the spare parts or any other things, and then fix it again. The overall process takes, maybe 2 weeks, or based on the company to company. Now imagine this particular battery is equipped with certain sensors, and based on, and this sensor data has been streamed, and based on that, your IoT application was able to predict, oh, this battery is getting into a trouble. And the IoT application already know what trouble is that as well, right? That information is shared to the field technician, and the technician goes with the right spare parts directly to the home and say, hey, you know what, your battery is going to get into a problem in under 3 days, and we came here to fix it, and they fix and go. Don't you think the experience with the customer is going to be improved or increased? Yes, right? So that is what IoT is being used in many cases for improving the customer experience. Yeah. And there is another example is a smart vending machine. I mean, I'll just show it in a video. What do I mean by smart vending machine? Yeah, this is, hope you can see my screen. This is a smart vending machine with not the typical dumb vending machine where you just see the products through the glass and you put a cash over there and pick the product, right? Here in the smart vending machine, based on the user, right, it recognizes the user. Like in this case, this particular person is a user, Mahira, and then based on the user, the products will be shown and historical purchase will be shown automatically. Like your wallets are connected. Based on that, purchase can happen. In this example, what you see in the vending machine is a mobile phone or IT equipment, but these vending machines can be used for multiple other ways. They can be used for beverages or cool drink, many other things. Beyond that, this interface is going to be an engagement platform between end consumer and the user. I'll give you an example. In one of the customer case, a smart vending machine has been put in India and one in Pakistan. Okay, if a person from India waves a hand, and on the other side, if the person in the Pakistan waves the hand at the same time on the screen, they both get a free beverage drink. And what are they? They're trying to engage the customer, and they want to take their brand to the next levels, right? In other case, they just give a game, short game. While you're walking on the street, you find these kind of machines, and they will show up a game, short game for 1 minute or so, where you go and play the game. If you win the game, you get a free cookie or free chocolate or something out of the vending machine. Or you watch a movie trailer, upcoming new movie trailer of your favorite hero over there in the machine. And when you watch the trailer in the machine, you get again a free goodie out of it. I mean, these are extremely different ways of engaging the customer. Here, IoT is not used for improving the efficiency, but rather more for engaging the customer and to make the customers more loyal to the brand. Yeah, this is one such example.
So, now, Pawan, we have last 10 minutes, Pawan.
Yeah, sure. Yeah. Okay, then I'll move on to the other one. In this way, the IoT has been used for the customer engagement. And finally, IoT is also used for generating new revenue models. What does it mean? I'll take an example of an air purifier company. What they have is a simple air purifier. It takes the bad air and gives you the good air, as simple as that, right? Now they won the bid with the government, one of the governments in Asia, okay? And then the point over there is, objective over there is, they need to provide purified air to the schools. So they fitted the air purifier over there. Now, how do they prove that the air is purified well? They inserted sensors. Now they get a report at the end of the day or so that, before purification and after purification, they kind of share it with the government. Hey, I'm doing my job very well. Now then they realize that if I know that how much purification I am doing, why can't I give these smart air purifiers, which are embedded with sensor, to the home market, like you and me? And they started selling to the home market. Now, what they started doing is they were able to not just monitor the purification of the air, but also they know when the filter need to be replaced. Okay, when the filter need to be replaced. Based on that, they were started giving alerts. Hey, your filter needs to be replaced in the air purifier in the next 5 days. Why don't you refill? Like if you need to pay a bill, a due date, how we get a message in a similar way. Okay, then they got another thought. Okay, if I know how much this guy is using, and I know when to replace the filter. Why should I even sell the air purifier? Why can't I give the air purifier for free to them? And based on the purification or purified air, I charge them. That is, we call it as a product as a service business model. You must be observing this kind of a business model quite often nowadays. In India, one of the water purifier company, instead of giving water purifiers to your home, right, they start, I mean, selling, they started giving for free, and then based on the liters of water you consume, they kind of charge based on that. So it is a product as a service. Drilling machine as a service, as you can see in the picture, right? Drilling machine as a, if drilling machine is being used for 5 hours, you will be charged for those 5 hours. The drilling machine you don't need to buy, you need to rent, and based on the usage, and the usage will be known based on the sensors that are embedded to it. So in this case, IoT is being used to create new business models, right? Product as a service. And finally, IoT has been used for edge computing cases. We know when is edge computing is needed. One is intermediate connectivity, and when security regulations are key, where you don't want to send all the data to the cloud. In typically with the defense customers we work with, right, they don't want to send any data to the cloud. They want to process everything locally. So in that case, edge computing is used. And if you need certain processing at the edge itself, when there is no connectivity and latency related stuff, in those cases you use edge computing. In one of the example is a Volvo Ocean Race. Yeah, in Volvo Ocean Race is quite popular and the most longest and toughest sporting event in the world, by the way. It spans across 45,000 nautical miles across 4 oceans, touching 6 continents. And during the voyage, they kind of touch 12 landmark cities over 8 months. This process, overall process, takes 8 months basically. Now, it is a race, right? Obviously, they wanted to win. Everyone want to win the race. In such case, the sensors, there are 2 kinds of sensors they embedded. One is the sensors with the sailors, like, you know, the heartbeat kind of things were measured, and the sensors to the boat itself. All boats look same. Now, who will win? Based on our performance, we win the race, right? So now, based on our heartbeat and the rest the sailors are taking, based on their fatigue and everything, and based on the boat performance, application was able to tell locally within the boat itself when to take rest, when to speed, when to do such things. These kind of guidance were provided by the application, so that these guys were able to make 1% improvement in the overall race, and they were able to win the game. So this kind of way also an edge computing can be used. I mean, you can try to understand how edge computing has been leveraged in a different way here. Okay. And another case, which is quite common for pharma also, by the way. Okay, this is not a pharma case, but this is for a cereal bar. You know, cereal bars that we eat during breakfast, right? A company which produces cereal bars, they get produced on the production line, correct? So what they want to do is they have taken the pictures of a right cereal bars and also broken cereal bars and all, and they trained the machine learning model in the cloud, and they deployed that model on the edge. Here, what they did is they put a camera at the production line, and within the camera, the machine learning model has been deployed. So whenever a new cereal bar comes in, the camera captures the image, okay? And that image is compared with the faulty and other cereal bars, and finally the algorithm will tell whether the cereal bar is being produced with a perfect dimension and perfect quality or not. And if it is good, it gets into the positive lane. If it is bad, it gets into negative lane. Okay, this is one example where IoT or edge computing is being used to determine the product quality at the production line. Okay, I mean, this is quite true for even pharma case as well. This has been observed with the pharma case as well when producing certain medicines. Yeah. And finally, another example is, you know, how there are certain cargo ships which goes onto the ocean. Like in this particular example, this particular company has 250 plus or 300 vessels, like ships, and they go to the sea, and each time they go to the sea, they stay for 8 months in the sea. Okay, and it is a business related, right? Lot many goods will be in between. They go to the store and give the goods to some particular country. They go back to the city. Lot of business happens within that particular ship, right? Now, all this inventory management, cash advances, if someone is getting down, de-embarking and all that, all these transactions needs to be carried out within the ship in the software. But there is no internet, right? The ship is based on the satellite connectivity. In these situations, what they do is they kind of leverage intranet, and they do the edge processing within the ship. And whenever the ship goes to the shore, they synchronize with the cloud for the update. It is as simple as when you don't have internet, you type in the Word document, and finally when the internet is back, you copy and paste to your email and send, right? As simple as that. Yeah. So in this way, IoT is being used across different ways. Yeah, I mean, to conclude, IoT is being used to improve the productivity, like we have seen assets and products within the assets. IoT is being used to provide better customer experience and to have new revenue models, new business models, and all with product as a service as an example. And finally, when in case of edge location, some processing needs to be done. That's where IoT is being used. And if I need to quickly give a heads up on where IoT is being used in the pharma, I think it will be covered in the upcoming sessions. But at a very high level, right, in a minute, in the pharma case, there are two cases where we observe. One is the production, the other one is a distribution. On the production side, as quality control is one such use case. Counterfeit is one such use case. How to avoid the counterfeit? Quality control is one such use case. Okay. The other case is a distribution. When you are distributing this pharma, right, a medicine and other things, many companies wanted to ensure they are maintained in certain storage conditions so that they are intact. Okay, there's a company in Europe which they kind of solidify the liquid medicine and they send to different countries over a ship and then liquidify this solid cube. Yeah, in the entire duration they need to make right temperature. So this kind of an example. I mean, Suresh, we have a time to go through this example, or shall I conclude?
Sir,
Sir,
please go ahead, sir.
Okay.
Okay. So in the supply chain, what happens is in the supply chain of this pharma drug, right? In this particular case, within the warehouse, the quality of the vaccine, in this case, it's a vaccine, this company where we work with, a vaccine where the quality of the vaccine is being monitored within the warehouse. That's fine. Now, when the vaccine is getting out and it has to go until the place where I really take the vaccine, that has to be maintained at certain temperature. Every vaccine manufacturer will tell what temperature need to be maintained. Now here there's a tricky thing. You guys know very well than me because you have the pharma background, right? So it's not about the vaccine is being maintained at let's say 5 degrees. It's more about time out of refrigeration. How much time the vaccine has been or a medicine has been maintained outside of the permissible limits. Every drug need to be maintained, should be maintained at certain temperature, and if it is not maintained for 100 hours, then it can become toxic or important, right? In that case, we need to not just monitor, okay, how many times the temperature has been fluctuating, rather you aggregate all that information. Okay, this vaccine has been produced in a plant in Visakhapatnam and it's or any medicine, right? And it has been sent to New Delhi or another country. In the entire transit, overall 15 hours, this particular medicine has been not maintained until it got sold to the end customer. Is 15 hours is permissible or not defined by the pharma company. So that kind of a use case has been done with IoT and track and trace applications. Yeah. So with that, I can conclude. I can conclude saying that, you know, the way how Internet of People has changed the world, we also see the Internet of Things is also going to change the world and make our processes more intelligent, intuitive, and interconnected. Yeah. So with that, I would like to conclude the session. We are open for the questions.
Delegates, please.
I have got one question. Am I audible?
Yeah, perfectly. Yeah.
Sir, as applicable to pharma field, we require to do risk assessment, hazard analysis of critical control points, fault tree analysis. So these are all the mandatory as far as the current guidelines are concerned. So in the IoT devices, when we are applying it, so what are the modalities which are present in case the internet is switched off but for any reason, and how to make the modalities so that we will not have any risk in the real-time analysis or control.
When the internet is not there, that is where the edge computing comes into the picture.
So how it will take the command from the remote place? What is the technology applicable there?
If I take an example, right, again, if I go back to that production line where cereal bar is produced, in that particular factory, there is no internet. It's an intranet. Within the intranet, or if you take the ship example, there is no internet. It's just intranet. Within the ship, you will have a certain processing edge computing device like a Raspberry Pi as an example. Okay. That particular Raspberry Pi, you are going to install all your software algorithms or modules which can determine the quality. And once that is done, you update locally, and when internet is back, it will be pushed to the actual application which is lying somewhere else. This is the process where it is being followed when the internet connectivity is not there. And as you rightly mentioned, regulatory pressure, right? I mean, if you see the point what I mentioned with pharma, it's extremely important to follow the regulatory guidelines. Okay, all these things will be done via the edge computing when there is no internet. Yeah.
Yes, sir. The second query is that in case of the real-time monitoring, because we have got under the strict control of security also, there are account breaches and so many things are happening. So a competitor may mutilate or do something. What are the security measures we can do in such a way that our program will not be overridden by another person's? He may be intentionally doing. Previously is unintentional, which has happened, but now intentionally somebody want to do it. What are the modalities we need to take care?
Yeah, so this is a quite common problem for any IoT use case, not only for pharma, for anything, right? If I am driving, if you take autonomous car and it is being driven by my, if you take autonomous car, if someone hacks that, I'll get an accident, right? So this is a quite common problem. Now, how do we ensure security and where do we ensure security? If I need to answer in the IoT world, there are three different ways we ensure security. First one is government regulations. Different countries are coming up with regulations saying that the data has to stay within the same data center within the same country, or the operations of the software has to be done within the same people within the same country who are recognized, especially for regulated industries. When I say regulated industries, defense, pharma, healthcare, all these are regulated industries, right? In such cases, the data has to reside within the same country. The operations should be done by the same country person, a recognized responsible person. Say, for example, if I am an Indian citizen, if such a rule is there, I only need to operate. If I am sitting in US, I am not supposed to operate, or some other citizen is not supposed to operate. Such kind of regulations are coming into place, which will help in certain way. The next is technology related. Where can IoT breach can happen? If you recollect the diagram what Suresh showcased, right, in the entire technology ingredients, you have the hardware, you have the software, the devices and software. In between, there is a piece called device connectivity, which acts like a broker, which takes the data from hardware, which will give to the software. And this is the place where a breach can happen. And this is the place because the hardware is there for how many decades? So many decades, right? And they know how to secure the world, secure in their own world. The software is also there for decades. They know how to secure the data within their own software. Now here you are trying to transmit the data from hardware to software. The broker can create a problem, right? And that is why in the technologically, in this particular area, more and more research is getting done to how to make the data transfer more secure, because I am taking from here and giving to there, right? So that is a technological aspect to take care of security. The third aspect is a philosophical, right? Every technology which advances will have security concerns, right? So there are certain things which we should not expose. We don't expose. I know in the current world where everything is getting exposed, right? All the data about us. If I go out, automatically everyone know where am I going, and I know the house is empty. Someone can come and stole my house, right? If I put something in a social media saying, hey, I'm going to Coorg for a 5-day trip, then I know there is no one is going to be there at house. So this is a philosophical aspect. How do we control security? By not exposing certain data, right? So all these, one is government regulation, other one is technological, the third one is philosophical. When you take care of all these three aspects, the security can be taken care. And this is more relevant for any use case, by the way. Hope that clarifies.
Yes, excellent, sir. Thank you.
Yep. I think Deekshita,
Only
you
one
have
more
some question, right?
please.
We request the participants, please post your queries in the chat box so that our speakers can take the questions and they can answer your questions. Participants, kindly note, if you wish to ask the question, you can unmute yourself and you can go ahead with your question, or else you can post your question in the chat box.
And also, before the another question comes up, an additional point for the earlier question is the privacy. I talked about security, privacy, right? I mean, we have seen video cameras, and the technology advancement also helps a lot, right? In order to identify a person, if a camera takes a picture, that's a privacy issue, right? But the technology is getting advanced so much that we no need to have video camera to identify a person. If my use case is to know how many people are entering the shop and how much time they are spending in my shop, I no need to have a camera to count. Rather, there are other technologies that are coming in where it can count how many people are coming, how much time they are staying, and who are the unique customers who are coming to my shop. So the such technological advancements also helps a lot. Yeah.
Thank you, sir. Technical persons, can I move ahead? Wow, what a great session it was. So marvelous to have a young, dynamic gentleman. What else a faculty development program needs? What a great coordination, syncing in between the two great speakers. Thank you so much, sir. You have taken all of us to another world for these 2 hours.
Yep. Thank you.
Sir, I'm extremely happy and privileged to say that our FDP had a very good start, and I believe a good beginning would have great ending. Sir, I convey my heartfelt thanks for being with us and truly making our serious sessions a very knowledgeable. You have taken our minds to another world of technology. We are proud of both of you, sir, for spending such a great time despite of your busy schedules. The session has truly given us a clear insight on how IoT has evolved, what are foundation steps in IoT, and various technology ingredients of IoT and applications. How to farm enterprise IoT platform like operation technology to information technology. The simple representation of complexity included in the computing network and applications related to sensor gateway. It was truly appreciable, sir. I hope the participants and all the pharmaceutical brains are in visualized technology space for the past 2 hours. Thank you so much, sir.
Thank you, and thank you everyone for joining the session, and really glad for us to speak to all the crowd. And definitely, I mean, our idea is to give a glimpse of how IoT is being used or how IoT is being formed. Okay, and our idea is to not to dig into the deep of pharma, which anyway you will understand in the next few sessions, right? If you have any further questions on how IoT has been leveraged across different industries, if you're keen on anything, please reach out to us on our Twitter or email or anywhere. Yeah, I mean, we are glad to provide more information.
Thank you so much, sir.
Thank you.
Sir, Suresh, sir.
Yeah, thanks, ma'am. First of all, providing this opportunity and this platform for us to provide some insights to everyone in the call. And as already Pawan mentioned, right, I will not again repeat that, but you can always reach out to us if there are any specific questions with respect to IoT. It's not just about the pharma, but any other industry also. You can always reach out to us.
Thank you so much, sir, having with us.
Thank you, ma'am.
Thank you.
Dear participants, we'll be having a sharp 10 minutes break, and we again join at sharp 11:30 for the second session.
Dear participants, thank you for being with us at the session 1 of the 5-day faculty development program, AICTE ATAL sponsored, AU College of Pharmaceutical Sciences, Andhra University. I would like to request all the participants to take a formal 10 minutes break and do join the same link for the session 2 at 11:30 a.m. Kindly note the timings of session 2. The session 2 would be streaming from 11:30 a.m. And I request all the participants to give your name, like when you're logging into this Google Meet link, kindly provide your name so that it would be easy for us to give the attendance part. And we request any of our participants. So do we should we like any technical issues or anything that we should provide from our end, you can just give in the chat box so that we would go with the modified things into the session 2. Any of our participants? Thank you. Dear participants, we'll just start our session 2 within 15 minutes. And we request all the participants to kindly join all the sessions of the FDP 5-day faculty development program, because the certificate would be issued to the participants who have coped with required attendance and also clearing the exam at the end of the FDP. Kindly note, dear participants, all the attendance of 14 sessions of the complete 5-day faculty program is required to attain a certificate from the AICTE portal. All the registered participants should show the attendance with minimum of 80% attendance and a 60% of score at the test conducted in the program. Thank you.
बसमध्ये इतका काही प्रॉब्लेम नाही राहत.
Okay, okay. Hello. Hello.
Hello, sir.
వినిపిస్తుందండి.
Yes, sir. Yes, sir.
అరే వీడియో మీరు ఆపుతున్నారా? వీడియో ఆన్ అవ్వట్లేదు.
లేదు సార్, మీరు ఆన్ చేయొచ్చు వీడియో.
నేను ఆన్ చేశాను, అది ఆటోమేటిక్గా టర్న్ ఆఫ్ అవుతుంది. ఓకేనా?
ఇప్పుడు చూడండి సార్ ఒకసారి. ఇప్పుడు వస్తుందా సార్?
నేను ఆన్ చేయగానే ఆటోమేటిక్ టర్న్ ఆఫ్ అవుతుంది. ఏంటంటే నా దాంట్లో ఏమైనా ప్రాబ్లం ఉందో తెలియట్లేదు.
లేదు సార్, ఇప్పుడు మీకు పర్మిషన్ ఇచ్చాను నేను.
నేను ఆన్ చేశాను, ఆన్ చేయగానే ఆటోమేటిక్గా టర్న్ ఆఫ్ అవుతుంది.
అవును, ఒక్కసారి సార్ వీడియో ఆన్ చేస్తే అలా అవుతుందా సార్?
అవును, వీడియో కెమెరా ఆన్ చేసినప్పుడు.
ఒక్క సెకండ్ సార్. సార్ ఇప్పుడు ఒకసారి వీడియో ఆన్ చేయండి. మీరు షేర్ చేయండి సార్ స్క్రీన్.
ఓకే ఓకే. ఇక్కడ ప్రజెంట్ నో అని ఉంటుంది కదండి, కనిపించట్లేదు. ఐ డోంట్ సీ ప్రజెంట్ నో ఆప్షన్. ఒకసారి మళ్ళీ లాగిన్ అవునా?
సార్
ఒకసారి ఇప్పుడు నేను క్లిక్ చేయనా వీడియో?
ఎస్ సార్, వీడియో ఆన్ చేయండి.
ఓకే, చేశాను.
అవ్వట్లేదా సార్?
ఒక్క నిమిషం, ఏమన్నా కనిపించండి. ఆటోమేటిక్ టర్న్ ఆఫ్ అవుతుంది. ఒకసారి కాల్లో
Hello. Hello.
Yes, ma'am. Like we are checking for the technical issue, ma'am. Like sir is unable to share. We are just sorting it out now.
So, is it clear?
We request all the participants to kindly keep all your microphones in mute mode And our second session would be starting within a few minutes. The second session is IOMT, Emergence into Different Health Spaces by Dr. Shivareddy Chella, Research Collaborator, Department of Cancer Biology and Pharmacology, University Illinois College of Medicine at Peoria. So we request all the participants to kindly cooperate with us. The sir has joined and sir had a little technical issue and we'll be sorting it out in a few minutes. Thank you. Sir, Shivareddy sir. Hello? Yes, sir, Shivareddy sir.
Sir.
Good morning, Shivareddy sir. Can you hear me? So your voice is not audible, sir.
Hello?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, can you hear me? Okay.
Yes, sir.
Yes, sir. Sir,
Okay, sorry for the inconvenience.
yeah, no problem. Sir, you can just share the screen, sir.
I already.
Yes, sir, you already shared. You just make in a full screen mode, sir.
Okay.
Slideshow, sir.
One moment then. I'll stop here it. The presentation information. Need to share it.
Sir, once again, can you please share the screen?
Yeah, if you want to share, you can share it. Otherwise. Can you see the presentation? Madam, can you see the
Now it is,
presentation?
yes, sir.
Okay.
Sir, just set it to slide share mode.
Slide share mode.
Yes, sir. In the bottom,
Okay.
just beside the 64% battery note. Yes, sir. Yes, sir.
Okay.
Just click it on to that. Please put it into the slide share mode.
Madam,
Sir, it is just behind, beside the 64% battery note, bottom
I did
right
it. I
side.
did just now I did it. Can you see it, madam?
No, sir.
One moment, madam. I'll just turn off the video and video mode. Simple. Okay. Madam. ఒకసారి మా పాప లైన్లో ఉంది, తనకి ఐడియా ఉంది, చేస్తుంది. ఒకసారి ఇప్పుడు నాకు ప్రజెంటేషన్ కనిపిస్తుంది, మీరేం కనిపించట్లేదు ఇక్కడ. ఇప్పుడు కెన్ యూ సీ ద ప్రజెంటేషన్ ఇన్ ఫుల్ మోడ్ లేదా? ఓకే, లైట్ షోలో ఉంది. ఓకే, ఓకే, నేను మేడం షేర్ చేస్తాను.
Dear delegates, please give us 2 minutes.
ఇప్పుడు షేర్ అయినట్టు లేదు, మా స్లైడ్స్ లో లేదు, షేర్ మా ప్రజెంటేషన్ అనిపిస్తుంది. ఓకే ఓకే ఓకే.
Sir, we go ahead like this.
యా
సార్ పైన స్లైడ్ షో ఆప్షన్ ఉంది కదా సార్, అక్కడికి పోయి ఫ్రమ్ ద బిగినింగ్ క్లిక్ చేయండి సార్.
స్లైడ్ షో ఆప్షన్
పైన స్లైడ్ షో ఉంది కదా సార్, ఆఫ్టర్ యానిమేషన్స్ టూల్ బార్ పైన సార్.
Soumya
టూల్
madam,
బార్.
ఎస్
we are sharing the slides. Here also it is not coming. I think there are few technical issues. Can we go ahead, dear participants, like this?
Sir Shivareddy sir, can you see the presentation, sir?
Yeah, I can see the presentation, but it is not in the slide show mode. But that's okay.
Now, sir. Now, sir.
But now also I cannot see the full slideshow presentation.
Hello.
Hello,
Sir.
Sir, click share slides here. PPT.
Sir, we are doing, but it is not.
Ma'am.
Dear delegates, please give us 2 more
Sir,
minutes.
corner side slide share option.
Yes, sir, we did it, but even though it is not, I mean, we could not able to do it into the slide share mode.
Okay.
Please wait, sir.
Okay. Okay.
Hello. Good morning, ma'am. Hello, ma'am.
Shivareddy sir, please mute yourself. We will be back in 2 minutes.
Okay.
So, dear participants, kindly excuse us for the technical issues. Now, it's my immense pleasure to introduce the speaker of the session, Dr. Shiva Reddy Challa, to the gathering. Dr. Shiva Reddy pursued his PhD in pharmacology from AU College of Pharmaceutical Sciences in the year 2009. He worked as Clinical Research Associate, BioServe Clinical Research Private Limited, Hyderabad, Senior Research Officer, Glenmark Research Center, Glenmark Pharmaceuticals Limited, Mumbai, India, Associate Professor and Head, Department of Pharmacology, Hindu College of Pharmacy, Guntur, Andhra Pradesh. Professor and Head, Department of Pharmacology, KVSR Siddhartha College of Pharmaceutical Sciences, Vijayawada. At present, he is rendering his services as Research Collaborator, Department of Cancer Biology and Pharmacology, University, Illinois College of Medicine at Peoria, USA. He has been Program Coordinator for PharmD program for 7 years. He had teaching experience in the courses of pharmacology, pharmacotherapeutics, pathophysiology, biostatistics, research methodology, and clinical pharmacokinetics. He had 7 years expertise of ward round participation, patient case discussion, and bedside teaching for PharmD students. He is an active member of NBA accreditation process. He had reviewed total number of manuscripts about 132 and had 36 research publications in reputed journals. He has guided about 49 PharmD students in their projects, and students were pursuing their PhD at present. His expertise include perform MCAO producers in rodents, pre and post operative animal handling, perform neurological evaluations, expertise in RT-PCR analysis, agarose gel electrophoresis, short hairpin RNA expressing plasmid synthesis, and purification of RNA expressing plasmid nanoparticle formulation, immunization of mouse with antigens, blood sampling, and statistical analysis. Preparing scientific illustrations, standard operating procedures, manuscript, standardization of new methods in lab. His professional honors and awards include Chukkupalli Pichaya Memorial Best Teacher Award in 2015, Professor P.C. Dandiya Award in 2017, Associate Fellow of Andhra Pradesh Academy of Sciences 2019, Dr. Reddy's Laboratories Junior Scientist Award in Molecular Biology 2020. Now, I welcome Dr. Shiva Reddy to deliver his lecture. Sir, it's over to you, please.
Sir, Shiva Reddy sir, kindly unmute and kindly unmute, sir. Unmute your microphone, sir.
So, thank you, madam, for introducing me. Can you hear me?
Yes,
Yes,
sir.
sir. Yes, sir.
Okay. Okay, now,
Please share your presentation.
okay.
Yes, sir. Thank you, sir. Please go ahead.
Okay, madam. Thank you, madam, for introducing me. And I am very much privileged to become a resource person, to be a resource person for this faculty development program. So, once again, I invite all the faculty members, faculty and research scholars, so all the delegates who are participating in this faculty development program. So this is quite interesting topic that I found when I go through the literature as well as with my experience. This is really an amazing topic. It's really maybe I hope everyone, all the delegates are going to be enlightened with this presentation. So okay, let me start my presentation. So the topic which was assigned to me is Internet of Medical Things. So when I see IOMT in the presentation, I felt like it is a quite interesting topic. When I started looking at Internet of Things, Internet of Medical Things, I see so many technologies recently came up. So particularly, I'm going to cover the many important areas where the Internet of Medical Things are going to be are already playing the role in various health spaces, like in terms of treatment, in terms of diagnosis, in terms of telemedicine, and remote remote treatment strategies. So I'm going to cover all those things. So first of all, I would like everyone to know about certain abbreviations which you are going to come across in this presentation. So particularly RPM, it stands for remote patient monitoring, so which is one of the important thing during this Internet of Medical. During this presentation, you will come across this some of the abbreviations. So PHI, this is protected health information. Maybe so I apologize here. PHI stands for protected health information. So usually this is particularly very important in case of USA. The USA has a HIPAA privacy rule. So HIPAA privacy rule indicates the how to protect the privacy or confidentiality of the patient data. So, during any transaction or during the therapy or during the Internet of Medical Things. So, so whatever the things which is playing with the patient data, which is involving the patient data, definitely they have to protect the privacy and confidentiality of the patient data. So for that, in the US we have a HIPAA rule, that is a Health Insurance Portability and Accountability Act. So similarly, in many other countries, we have some certain guidelines to protect the patient data. And similarly, okay, RFID technology recently, it's not recent, okay, almost like this technology came into existence long ago. So this is radio frequency identification technology. I'm going to talk briefly about the Internet of Things first, okay, before my presentation. Some of the things which I am going to cover, these things, okay. Artificial, okay, I'm not going to touch upon much about artificial intelligence, but you will come across about these abbreviations during the presentation. So let us see the statistics and market value of Internet of Medical Things. Before this, okay, I would like to explain what are the Internet of Things. So with my real life experience, okay, I can give you some examples. Okay, in my lifestyle of US, particularly when we go to the like supermarkets like Walmart or okay, Sam's here, so we see the particularly the Walmart the agencies, okay, the agents or executives, they can identify them tracking the any item which you need it. So they are going to use one particular device to track the things, okay, in the supermarket. So that is mainly based on the this particularly it mainly depends on the RFID technology. So in case of RFID technology, it has two components. The one component is RFID reader and the other component is RFID tag. So whatever the thing we are going to track it or identify it, so that has the tag, and similarly the reader whatever we use it, okay, that has a reading capacity through using the Bluetooth or network, various networks. So this is one example of Internet of Things, and so in my apartment, okay, we use a laundry machine. So when we go to laundry machine, we just use we use the cell phone to operate it, and then we just pay the money. So everything is done with the mobile. So whenever the phone is it is very close proximity to the machine, so automatically it will identify the person. Okay, our account is linked to the automatically that machine. So here, thing is that this is also working based on the principle of RFID technology. So RFID technology has completely, so it is very useful in case of Internet of Medical Things also. First, I would like to introduce to the faculty members, like the things which are commonly used in our real life scenarios. Okay, this is the one example, and so let me tell you. Okay, while driving the car, so my mobile can say, my mobile can easily track, okay, how much speed I am going and how many times I applied the brakes. Okay, this is like this is also working based on the Internet of Things. So like this, we have many more examples in the real-time scenario. So you just don't consider that okay, Internet of Things is not a complex or very like a huge equipment or instrument, something like that. So it can be small wearable device, or it can be a small like tag like thing, okay, anything. Small devices can be coming under the Internet, okay, as small as like a small tags or small devices, or sometimes okay, even it is as big as a robot, or okay, sometimes as big as drones. So we used drones recently.
Excuse me, sir. Sorry to intervene. Your presentation is not visible, sir.
Presentation is not visible.
Sir, it's visible, sir. Satyanarayana, sir.
We'll check, madam.
Sir, is it same with the other participants also? Can anyone just? Hello.
No, madam, it is visible.
Visible, no?
No,
Yes. Yes.
No, it is not visible. Yes.
Visual, but do not proper.
Hello, madam.
Yes, ma'am.
Not visible, ma'am. Actually, it is like a part of the screen, madam. It's not
Ma'am,
full
Correct.
screen.
Yeah, not in the full
Yes,
screen.
yes,
Correct.
yes.
Very much that.
Yes.
Like all images are there, it is also one part.
Just pin that
Yeah.
image.
You can
madam.
just pin the
Okay,
screen.
you have to pin the screen. Yeah, thank you, ma'am.
Yeah, ma'am. Sir, participants, you just pin the PPT. What is the pic you are seeing? You pin to the screen. You just click the option so that screen will be visible for you.
Okay. Can I go ahead?
Sir, is it okay, sir, participants?
Yes, ma'am.
Yeah.
Yes, ma'am. It's okay now. Thank you.
Thank you. Thank you. Yes, sir, you can proceed.
Okay, thank you. Yeah, this is the more important for the participants. Okay, participants to be able to see the presentation, then only it will be more fruitful. Okay, so I would like to talk about statistics and market value of Internet of Medical Things. So the global Internet of Medical Things market was valued at $44.5 billion in 2018. It is expected to grow to the $254.2 billion in 2026. So according to this global market research reports, and similarly, the Forbes is well known, which is declared that there are currently about 3.7 million medical devices connected to the computer system, monitoring the various parts of the body. They inform about the health condition of the patient. So all these devices, wearable devices, are mainly connected to the computer systems, and then they will transfer the data to the healthcare professionals. So about 51% of healthcare providers have said they are ready to implement the IOMT to drive more sales and innovation. And Goldman Sachs estimates that IOMT will save the healthcare industry 300 billion annually in expenditures, primarily through remote patient monitoring and improved medication adherence. So we see these IOMT it is also playing role in medication adherence. When the patient takes the medication, automatically the alert may reach the mobile of healthcare professional. So similarly, in 2016, the global smart pill market was worth $179.9 million. By 2025, it is expected to rise further. So let us see what is the classification of IOMT devices based on the setting where they are used. So I simply presented in a simple, easily understandable manner. So like the wearable devices, all the devices which can be used on the body segment or in the home segment or community segment, clinic segment and hospital segment. So based on the usage of the location, and the where exactly, whether it is used in the community or hospital. So based on that, I just mentioned all the. To the first one, on body segment. On the body segment, the body segment can be broadly divided into two categories. One is consumer health wearables. Recorded in the mobile phone, and there are so many examples. Even I could not go through the many examples because there are numerous examples which I cannot present all of them in this presentation. But at least I can say I can present some of them here. And most of these devices are not regulated by health authorities. So whatever this Internet of Things which are coming under this category, particularly consumer health wearables. So here, these devices are not regulated by health authorities, but may be endorsed by experts for specific health applications based on the informal clinical validation and consumer studies. Since these are most commonly used in the like normal lifestyle without any disease, so these are not regulated by the regulatory authorities. So that's why they mentioned here consumer health wearables. And so in case of clinical grade wearables, that thing is different again. So companies operating in this particular space include Misfit, Fossil Group, and some of the companies which are offering these devices. Let us see the body segment in Internet of Medical Things with respect to body segment. Okay, so I explained The same, okay, in this slide particularly I mentioned about consumer health variables. But okay, here I am talking about clinical grade variables. So examples include a smart belt from active protective that detects falls and deploys heat protection for elderly wearers. So in this case, they are more used in uh, more used okay, on the recommendation of the physician most of the time. So here we have smart belt from active protective that detects falls and deploys heat protection for elderly wearers. We see in case elderly patients are very easily prone to the falls, and they might likely experience the body fractures. So these biomedical devices are very much useful for elderly patients to identify the likelihood of the fall or something like that. So and then Halo Neuroscience Halo Sport headset, so which is worn during the workouts and physical training to stimulate the brain areas responsible for muscle memory, strength, and endurance. So similarly, we see Neuromatrix Pel, which is a wearable neuromodulation device that taps into sensory nerves to provide relief from chronic pain. So these are some of the examples, but I did not go through much about the more details. Okay, some of the devices. Okay, I can discuss a little bit more elaborately. Coming to the clinical grade variables. So here, particularly the personal emergency response systems and remote patient monitoring, and then telehealth and virtual visits. So in case of particularly out of these three things, we use certain biomedical devices in case of emergency response systems. Particularly, these are very useful to give the emergency care. So because okay, whatever the data which is generated are some of the physiological parameters which can be measured in advance before reaching to the hospital or before getting the first aid. So provided they should have the basic biomedical devices like biomedical devices to measure the heart rate, BP, and some of the temperatures like oxygen saturation, temperature, and these things. So similarly, remote patient monitoring also plays an paramount role. So we see in case of COVID situation, many other than the patients who suffer from the chronic disease other than the COVID, we don't have. Okay, then they are completely confined to the home. It is very difficult to get the treatment. So in such cases, the remote patient monitoring has helped a lot for the patient. So this Internet of Medical Things, if it is really utilized in a proper way, it is a blessing. The only thing is we might need to regulate we might need to protect the patient data so more carefully, whatever the sensor, okay, whatever the devices which we are using. So we should be able to protect the data. Then okay, they are like really a blessing for the healthcare system. So this has revolutionized almost the healthcare sector. If you come to know all the applications, you really appreciate it about this. Okay, so in case of remote patient monitoring, yeah, you are going to, for example, okay, so the patient has undergone the surgery and then post-surgical care. So we need the physician has to monitor the patient on daily basis. So in that case, they are going to give some biomedical devices. Particularly, they are going to talk, make the phone calls, and they are going to use the basic biomedical devices. Okay, how he is doing and how he is okay. For example, disability patient, so our post-surgical patients, how they are being recovered on daily basis. So they have specific biomedical devices. Okay, they are going to give the data and they are going to transmit the data to the healthcare professionals. Based on that, okay, the subsequent therapies will be followed. In case of telehealth and virtual visits, so we are giving presentations online just like that. Okay, so telehealth, virtual visits. So virtually, physician can see the patient and he can talk to the patient. So he can discuss, okay, what are the real health problems, and he can explain the medications, and okay, many the other things in terms of diagnosis. So telehealth has it is a separate session. We need to cover it in a big session. But anyway, so I'm touching all of them a little bit. Coming to the community segment. So here, in case of community segment, okay, what are the different areas where we need to use the internet?
Sir, please share screen. Excuse me, sir.
Pardon me.
Sir, please share screen.
Sir, it's visible, sir, for us. We can see the screen.
No,
maybe after moving the slide, okay, are you not
The Shivareddy, sir, we are in this slide of community segment IOMT.
Yeah, that's correct.
Yes. Still, any other participant facing the same issue? Sir, Satyendra Kumar, sir, you just pin the PPT to your screen.
Small size.
Yeah, you just pin it. You can see the option there. You just pin to your screen so that it would be visible in full screen.
No view.
Can you see it?
Sir, is it okay with the other participants? Can anyone just give reply in
Yes,
chat
ma'am.
box?
Yes, we can able to see.
Okay, fine. Okay, sir, can we continue?
Yeah.
Sir, Shivareddy, sir, you can go ahead.
Okay, thank you. So in case of community segment, we have mobility services allow passenger vehicles to track health parameters during transit. So certain biomedical devices, they are particularly used when the patient is in the mobile condition, like ambulance, so during the transit period, and some of the things, they are like emergency response intelligence is designed to assist first responders, paramedics, and hospital emergency department care providers. But I am not going details about what are the biomedical devices which are used. But there are certain biomedical devices which are useful in case of emergency care during the transit. This is okay. So, and kiosks are physical structures, often with computer touchscreen displays that can dispense products or provide services such as connectivity to care providers. Kiosks are physical structures. Like, let me give an example. For example, when you go to the railway station and reserve the ticket, we see some physical devices where you can enter your details. You can check it. So like this, we have some physical structures before entering into the hospital, or some of the maybe you can schedule an appointment in that, or you can pay the bills. So in case of USA, for example, I am going to the hospital called OSF. So OSF Healthcare has provided us a medical app. So in this that app name is OSF My Chart. So it's really amazing app. It is unbelievable. We can do everything in that. We just either in the mobile or in the system. So I can just log into the computer and I can see what are my what are my previous visits, and what are my blood tests. And so if I want to go ahead with the scheduling an appointment, I can pay the bill. I can do everything almost like this is completely regulated by the hospital. But so you can also log into that. So hospital has given authority to access that OS of my chart. for each individual patient. So you need to maintain the password and everything more confidential, because so your patient, particularly for example, in my case, okay, I need to protect my data, my health data. So otherwise, if the health data is it is breached, okay, it is hacked, then okay, so these things will be going wrong. So that is the reason. Okay, these are like yeah. Okay, so the technology is more okay, useful, and so everything. Okay, so before going to the hospital, okay, they are going to ask all the, for each visit we have a survey. So they will send the survey, and okay, we enter all the details. Okay, last time, okay, what are the current problems? Okay, why we are going to meet the doctor? So all these things are like this. Okay, for each hospital we have a specific app. So such type of things. So before reaching to the physician, so we can enter the data so the doctor can see it. Okay, and it saves a lot of time to the physician as well as nurse. And so okay, and even you can save your time. Okay, so obviously it is highly productive, and efficiency is going to be increased because okay, it consumes less time and less money for everything. So next, point of care devices or medical devices used by a provider outside of the home or traditional healthcare settings. So for example, in a medical camp, so the medical healthcare providers, they go to the camp, or they uh, temporarily they will have so many biomedical devices, so they can measure like glucose levels, or they can measure temperature. So point of care devices are the like any devices which can rapidly diagnose your disease. Like okay, in case of COVID, we have a rapid test. So something like that. Okay, so whatever the diagnostic devices which can, like a pregnancy test. So these are all coming under the point of care devices. So which will quickly give the diagnosis. Okay, so well, they are very handy, and then they are very user friendly. So it is very easy to do the diagnosis. So in each device has a particular benefit. So coming to the logistics, during okay, transportation also. So some of the things, Internet of Things we use during transport, for example, to identify the to trace the particular medical equipment. So we have I told you, okay, like this technology. So for tracking radio frequency. Hello, can you hear me?
Yes, sir.
Yes.
Clear.
Okay. Okay. So using the RFID technology, you can track everything like okay. So like for example, in case of COVID, we suffered a lot. We suffered due to the lack of awareness about the how many beds are available, how many volunteers, how many ventilators are available. Before reaching to the hospital, the emergency vehicle should have the data about the okay, how many ventilators are available, how many beds are available. How is this possible? Because so using RFID technology, is for example, all the beds are tagged with the RFID chips, okay, RFID information. That is how okay in the US, okay, all the medications are they are tagged with the RFID tag. So okay, even while giving the infusion, so just okay, now nurse is approaching here. Okay, just she will scan the tag, and she is going to get the price of that medication, and okay, she is going to get everything about that medication because everything is embedded in that radio frequency tag. So that's how you can okay, one can use even the you can regulate many things when you are not able to without going to without physically going to interact. So you just in the online, okay, okay, by this will work. Okay, this RFID technology will work only within the hospital. Certain area only it covers. So hospital should have this data. So how many beds are available, how many volunteers are available, that data has to be presented by the hospital to the government authorities. so that they can government will come to know. Okay, so they can keep this data in the public domain so that everybody can reach that data. So okay, like this, okay, we have many applications of IoT. So coming to the clinical segment, this segment includes Internet of Medical Things devices that are used for administrative or clinical functions, either in the clinic, either in the telehealth model, or at the point of care. The point of care devices here differ from those in the community segment in one key aspect. Instead of the care provider physically using a device, so the provider can be located remotely while a device is used by qualified staff. So it's unlike the previous setting. So here the point of care devices differ from those in the community segment in one key aspect. Particularly, so instead of care provider physically using a device, here the point of care device is not operated physically right from the location. So this is operated by somewhere else. Okay, from some other location, he is going to remotely operate this device.
Sir,
So that comes
sir,
under this.
Shivareddy sir, we have a query from Arun Kumar sir, like he raised the hand.
Okay.
Sir, Arun Kumar sir. Arun Kumar sir. Screen is not being shared. Sir. Okay, sir. Shivareddy sir, you can continue, sir.
Okay. So is not able to see the screen?
Yes, sir. Like screen is not being shared. Participants, is it the same with any other? Can anyone just confirm?
Madam,
No, ma'am.
my name is Swapna.
It's
May I
visible, ma'am. We're able to see.
I will see.
All are able to see now, sir?
Yes.
Yes.
Okay, fine, fine. Sir, Arun sir, can you just pin the screen to the, you can just pin to screens at the option. Sir, Shivareddy sir, you can proceed.
Okay. So there's some of the examples I mentioned here. Resilience Clinic in a Bag, which is a cloud-based examination platform for clinicians to assess the performance at any point of care. So you can explore more about these things. So even I did not find much time to explore. There are many things which is beyond the scope. Almost we cannot cover within 1.5 hours. So here, Think Labs digital stethoscope and ThyroCare's comprehensive telehealth patient examination device for the heart, lungs, ear, and skin. So for measuring the temperature. So anyway, this presentation is available, so you can explore more about each and every app. Okay, whatever the tool which is mentioned here. So in hospital segment, asset management monitors and track high-value capital equipment and mobile assets, such as infusion pumps, wheelchairs throughout the facility. So this is what I was mentioning about it. The managing or tracking the equipment or whatever the for example, how many infusion pumps are available, how many wheelchairs are available, so we can track everything using the RFID technology. So even so in our labs, okay, we use the pipette. Pipette also I can sometimes, okay, when I miss the pipette, okay, I can use the RFID technology to track it. So while doing the experiment. So then like this, okay, we may not be aware of all the applications. So some of the applications which are highly related to the medical field. So recently in the pharmacy also I'm going to talk about maybe in the coming slides. The pharmacy inventory management and everything is happening with this technology. So let us see, okay, here patient flow management improves the facility operations by preventing patient flow management. Okay, so when patient is entering, patient also be maybe tagged with tagged. So we'll come to know, okay, which patient is coming into the hospital setting, and okay, then we can also control the patient flow management. It improves the facilities operations by preventing bottlenecks and enhancing patient experience. For example, monitoring of patient arrival times from an operating room to post-care to a ward room. So, okay, like this, okay, the patient where exactly he is moving within the departments, they can identify that. So, inventory management streamlines the ordering, storage, use of hospital supplies, consumables, and pharmaceuticals and medical devices to reduce inventory costs and improve staff efficiency. So even this one, by using this, having the tag system, so we can avoid many medication errors, and the efficiency of the inventory control will be definitely improved. So in a real scenario, okay, if you talk to the pharmacy managers, you will come to know many other things. So like, okay, in a hospital segment, particularly, I would like to talk about here. There are three things like I mentioned which are quite interesting. So innovative devices include Joel's wearable defibrillator, so which continuously monitor patients at risk of ventricular tachycardia and fibrillation. Joel's wearable defibrillator. This is so maybe it works on the principle of so in case of Internet of Medical Things, we have many times so the medical device is maybe it is also linked to the mobile applications. So we need to install the mobile app. So many of them, okay, we need to install the mobile app. Some of the devices which will work without app also. So like I mentioned, some of the examples, like when you sometimes when you are using the Apple phone, so you don't have to use any medical device. But okay, so sometimes when you use the only phone itself, it can tell you the activity and those things. Sometimes okay, we have medical devices without installing any app, we can it can transmit the data like through. So there are some devices which I came across. So then we don't have to use the mobile app also. So Stanley Healthcare Hand Hygiene Compliance System, okay, which is very good, which incorporates an occupancy sensor and a real-time location system, a real-time location system receiver to track the identity of employees using the dispenser, and uses analytics to determine whether employees are following hygiene protocols. So this is particularly useful for the maintenance of sanitation and hygienity within the hospital in a particular setting. So for this also we have some of the I do not know exactly so where exactly the system is, in which hospital it is used, but definitely so you can explore more about it. Stanley Healthcare Hand Hygiene Compliance System, and Boston Children's Hospital GPS-based MyWay app, which guides visitors to their destination using the quickest route. So in the hospital, okay, there it will guide you to reach to the quickest route. So application may be different in each app. So like in case of COVID, we use different apps like Selfie app and then Arogya Setu app. So we have so many medical, smartphone apps to use it, but each app has different application. So okay, here IoT communication and technology. So how IoMT, the communication happens between three important components. The first one is IoMT wearable devices. So here either sensor or wearable devices, or sometimes even embedding systems. So certain things are embedded in the skin of the patient. So that is also coming under the IoMT. So these things, from this, the data is going to be transferred to the mobile phone or computer. Okay, and then here it is going to be transferred into the cloud platform. So total data. So when you have the data of so many patients, so it cannot be stored in a normal thing. We definitely the hospitals need cloud platform. So for that they need to invest lots of money. Maybe so one of the challenges for this IOMT is implementation. Okay, particularly the privacy is more important challenge. But so similarly, the implementation with respect to investment, so it is little expensive. So that is the reason maybe some of the hospitals, particularly the big hospitals, they have more hospital. They extended the chain like hospitals all over the country or all over the state. So such people, they can easily maintain the cloud platform. So they can implement more Internet of Medical Things very easily. So a small clinic, they need to operate they need to store the data. They need to invest some money initially. So it depends on the how much data. So I don't know. Okay, again on the cloud. Okay, on the cloud, regarding the cloud and the big data, I don't know much about it. But definitely, we are storing the patient data. We need the cloud platform. Otherwise, so it is not easy to store it. So coming to the different layers, which are commonly seen in this IOMT. So first you see the IOMT device network. So from here, okay, so it reaches to the IOMT communication network layer. So you see here, okay, what are the IOMT device network sensors, and okay, what are the devices, biomedical devices which are used. Coming to the communication network layer, so you need to have some network like local area network, core network, or access network. So from here, when it reaches to the IOMT platform layer, the service support and here cloud computing. So the middleware technology. So these things are coming under the IOMT platform layer. But ultimately, when the data reaches to the IOMT platform layer, so from there, so the doctor is going to, the physicians, all they are going to analyze the data and see they'll discuss. And finally, they'll come up with a solution to the patient. So that is coming under the application layer. So detection, monitoring, prediction, tracking. So yeah, medical record, telemedicine. So all these are coming under the IOMT application layer. Finally, so we are the healthcare professional is going to deliver the therapy. So that is the ultimate application layer. So let us see what are the benefits of Internet of Medical Things. So if you see, already some of them we discussed. Improved drug management. So here, the treatment management will be definitely improved because. So I'm going to discuss some certain things like the smart pills. So smart pills and they have 3 applications. So all those things definitely are going to improve the drug management and improve the disease management. So here, remote patient monitoring, so which we discussed, improved diagnosis. So definitely, the diagnosis will be improved because of biomedical devices like. So in the sense here, okay, sometimes when patient is in the remote area also we can diagnose, and sometimes the self-diagnosis is possible. For example, in case of COVID, so here for the saliva testing it is very easy testing, and sometimes when you do the rapid testing of any diseases, diagnosis of disease, so there the self-testing is always better. Okay, we don't want to put some other person on the risk. So for example, if you go to diagnosis for the healthcare provider if you go to the healthcare provider for the diagnosis, then okay, so in case of contagious disease, okay, you are going to put the physician or nurse, okay, you are going to put them on risk. risk of being infected. So that is the reason to avoid the infection to the healthcare professionals. So it should be like either self-diagnosis or robot-based diagnosis. So since robots are not infected, robot-based diagnosis is always safer in case of contagious disease like COVID. So one way that's really helpful. So either in case of contagious disease, we need to prefer either self-diagnosis or we need to follow the robotic technology. I apologize. Okay, here I spelled wrongly. So diagnosis. Okay. So low per patient cost. So when the patient is taking the treatment, so from the home, so patient is going to save the complete traveling expenses, and then he is going to minimize the cost of the therapy. So even physician also is not going to charge much. So again, in either way, so physician is going to be benefited as well as the patient is also going to be. Physician is benefited because he can do the visit. He can complete the patient visit by online. So within it is pre-scheduled like that. And then real-time monitoring and real-time evidence. Particularly, I would like to emphasize on this benefit, real-time evidence. So, for example, usually when the patient is suffering at home, and then during suffering we cannot directly get the treatment. So when somebody is suffering, directly when you have the remote patient monitoring, so during the suffering itself, they can see the real-time how the things are going on in your body. So, for example, if you have a oxygen saturation this much and temperature, so when there are real-time evidence is much more useful to the physician to change the therapy very rapidly. So even so let me use the example of hypertension. So in case of hypertension, so whenever our BP is raised at home, okay, so we bothered about it. So when you go to the physician, so after going to the physician, it will come down. So BP will be normal after going to the hospital. So this is something like called pseudo hypertension. So the hypertension. So we see the blood pressure high at home, but after going to the hospital, it disappears. It will come to the normal. So this is something like we cannot give the real-time evidence, real-time monitoring. So here, so this is particularly possible when you use the Internet of Medical Things directly. For example, whenever you have the episode or something, so immediately the medical device will immediately send the data to the physician, healthcare provider. So I would like to give one more example in case of white coat hypertension. So patient may not be having the BP. BP is normal at home, but when he goes to the doctor, so by looking at the doctor, his BP is going up. So in the reality, reality is different. So similar just like that. Okay, glucose levels also. So many things happen. Okay, directly when we have the problem, when you have the health problem, that time, so you cannot directly meet the physician. So it's not the real time. So we are going to complain to the physician that okay, I suffered from breathlessness during night. So these things are happened during night time, but we are reporting in the morning. So that is called real time evidence. Real time, in case of real time evidence, so for example, if the glucose levels are going down for you, immediately the medical device will send the alert to the physician. So that is the real time evidence. And then improved emergency care. So in case of emergency care also, so the things are happening. So before you go to the hospital, for example, if somebody had the stroke, ischemic stroke. So if the physician, okay, if you have primary care physician, okay, if the physician will come to know about your stroke, so all these symptoms before you reach the hospital. So, so here in case of US, Okay, the entire data is available with the primary care physician. Okay, for example, okay, when we go before we go to the hospital, so when we just call them and we had some symptoms, then automatically we can also enter the data at home. Okay, these are the symptoms, so they will. So then when we send the data, automatically they can get ready with the therapy by the time we reach the hospital. So this is how things will be working. So it is more efficient as well as effectiveness. So the patient care it definitely is going to be more effective as well as it is more efficient. Okay. So efficient is different and effectiveness is different. So efficient means we are able to save the time, money, and everything. Okay, so let's move on. So we have challenges of implementing IOMT, particularly so whenever somebody is developing the biomedical device, they need to standardize the medical devices. I mean, standardization, validation of those medical devices. So maybe there may not be some standardization protocol existing in the place. So if that is a new medical device, many people are, standardization protocols are not existent. So it is difficult to have the standardization validation procedures. So that is also one of the important challenge. And then regulatory challenges. Okay, particularly recently many of the biomedical devices are also the HIPAA rule. Okay, whatever the rule I mentioned, HIPAA rule. So that is also applicable to all the biomedical devices. So which was particularly implemented in the US. So the US FDA is going to regulate all the biomedical devices, and they also all biomedical devices are going to cover under the HIPAA rule. And coming to the security vulnerabilities, so this is a major problem with these biomedical devices. So there is every possibility for the breaching of the data, and so the patient data is theft. Okay, so in the uh, big hospitals, if the softwares are not protected properly, the entire patient data will be hacked. So most of all the patients' data in the hospital may be hacked. So we see the news in the US sometimes. The hospitals are going to pay the big ransom, and they are going to be the entire patient data is going to be hacked by some hackers. So then in that case, the hospitals are going to be penalized by the US FDA, penalized by the department here. So not only this country, any other country. So we have very stringent rules to protect the data. So when the patient data is disclosed by chance or by choice, so whatever the reason, but there are certain punishments and penalties for that. So here hospitals are going to pay the $1 million, $1 million, $2 million, millions of dollars when they're not able to protect the patient data. So recently, blockchain technology came into the existence. Okay. It's not like very recent. So something like it evolved around 2000. I'm not sure exactly, but it falls around early 2020, 2012 or 2013, something like that. But it has become very popular very recently. So blockchain technology is a technology which cannot be easily hacked. So that is the reason the total healthcare industry is looking at the blockchain technology to protect the healthcare data of the patients who are belonging to a particular hospital. So and then high infrastructure costs. Okay, this is what I mentioned. Okay, for maintaining the cloud and for maintaining the data in the cloud, they need a lot of space and investment. So these are the four important issues which are particularly we come across during the implementation of IOMT. Okay, so in this, okay, particularly my title of presentation is okay, emergence of different health spaces. Okay, how Internet of Medical Things entered into the different health spaces or different health areas. So I covered most of them here. Particularly, I did not mention until now about the clinical trials. So in the clinical trials also, the IOMT has entered because okay, so during the clinical trials, the main advantage is so we can directly, for example, if we have the real-time data of the patient. So even here also, okay, everything is okay. Patient is given with the some medical devices to track the entire study data. So they will get the data. So earlier days, unlike earlier days, the patient comes to the hospital visit, then only we can get the data in the clinical trials. But now things have become changed. So then things have radically changed because so you will get the real-time data about the clinical trials. So if something went wrong, okay, for example, if somebody wants to stop the clinical trial, they can abruptly stop the clinical trial, and they can make a lot of changes. Decision making. Okay, so I did not tell about decision making. So even in the clinical care also, clinical decision making can be changed. The decision making becomes very easy when you have a real time evidence. So if something is happening to the clinical trial participant, so using the biomedical device, all the investigators will come to know about that. So there is a very quick communication about the data. So because as a result of this, with the introduction of IOMT in the clinical trials, so it has changed the phase of clinical trials also. So I mentioned here most of them. Okay, we have covered. So fitness and lifestyle. So that's what we see many apps on the Apple phone. We can see how much work we are doing, how much activity. Everything will be recorded. So these are more useful in case of disabled patients and post-surgical patients who are going to recover. So and we can see the diagnosis of vitals and simple hematological parameters. So these things, okay, so we can do at home. So using the devices, we have so many biomedical devices to measure the temperature and all these things. Okay, so coming to the COVID only, I need to talk more. So here I mentioned one of the application, the prevent and control of spread of contagious diseases like COVID-19, and safe testing and diagnosis of COVID-19 and COVID by the by using the robotic technology, and social distancing also can be monitored using the biomedical devices, and so we can and tracking the infected and suspected and quarantine personnel during the COVID. So we can track infected patients, suspected patients, and then the personnel who are in quarantine. So these biomedical devices can they have wide applications in case of contagious diseases. So I'm going to show you some of the apps in the coming slides. So recently, so even drug delivery. So drug delivery and okay, I mentioned about smartphone. I mean, smart pills. Smart pill technology mainly useful for drug delivery and for improving the drug delivery and as well as medication adherence and smart pill endoscopy. So somebody is going to given patient or any personnel is going to be given the pill. So that okay, we know that okay, in case of normal endoscopy, so we have a camera at the end of the device. So when the physician is going to introduce into the stomach, so that the camera is going to capture so many photos inside the stomach, and then it is going to reveal all the photos, all the images. So in this case, instead of the device which is introduced. Okay, so we are just giving a small pill, so that pill will do the endoscopy for the patient. and even drug delivery also. Okay, I'm going to give you some example in the maybe coming slide. On the treatment in the elderly patients and disabled patients, okay, I mentioned in elderly patients, particularly the likelihood of the fall. Okay, so we are going to medical devices are going to give the alerts before every chance of falling. So this will prevent the lot of bone fractures. So for the elderly women, it is more important because so when they are okay, in case of postmenopausal women, they have due to the lack of oxygen, they are easily vulnerable to the fractures. So this is, I think you must be knowing about this recently. A cardiogram. Okay, we can see the ECG electrocardiogram in the mobile apps. It is mentioned as a cardia. Actually, it is app is known as cardia. Okay, sorry, I forgot to mention the name here, but okay. So recently, we have we got the app to record the ECG of individual person. So this is one. Okay, I'm going to give many examples of these devices. So recently we see Google Glass during a patient visit. So usually the physician during the when the patient approaches to the physician for the patient visit. So during that time, okay, the physician is going to wear this glass. So this is just like looking like a or glass, that like spectacle. But so here, this company which is providing is Agumedics. Agumedics is a healthcare startup that uses Google Glass to provide a remote Skype service to physicians and clinics around the United States. So here, okay, whatever the discussion that happened, okay, whatever the visit that happened, okay, that will be completely captured by the Google Glass. So that data will be so that data can be easily saved in the computer with enterprise grade HIPAA security. So this has HIPAA security also. So Agumedics offers the nation's most reliable and most scalable remote Skype service. So you can explore more about remote Skype service. Then physicians wear Google Glass while seeing the patients, and the visit information is sent to a remote Skype that records all of the patient visit notes. So this will save the lot of time to the patient. So particularly, I'm working in the context of United States. So here, when you go to the physician, he will sit in front of the computer and keep on typing something. So it takes a long time. Okay, instead of focusing on focusing on the diagnosis, so he is focusing more on the entering the data, so on searching the data, and okay, he is so particular about the data because the rules are stringent. So that is the reason. Okay, he is going to be using this Google Glass, so we can save the physician. No need to type anything there. Just okay, it will record everything. So okay, later on, somebody can type the data on the behalf of him. So certain things maybe we can avoid using this Google Glass. So this is Akumin. I think you must have seen in WhatsApp messages. Okay, we see in lots of WhatsApp messages. So this is a device which that enables the visibility of the beams. So where exactly they are located on the human systems. So using this, okay, so we can the phlebotomist, okay, he can draw the blood sample very easily. So by exactly inserting the needle in the right location. So these devices are making the things very easier. So I don't know. Okay, maybe there may be so many other applications, but still, okay, I know particularly in case of blood sampling, they are very useful. So it's the artificial pancreatic system. So this is called as open APS. So earlier days we have only cesium. So monitoring continuous glucose in case of diabetic patients. there are some devices which will monitor the glucose round the clock in our body. So this particular artificial pancreatic system is again the specialty of this is, so it is also going to inject the insulin based on the glucose levels present in our body. So here it does this by monitoring continuous glucose monitor data, algorithmically determining when insulin doses should occur, and issuing the commands to the insulin pump to deliver these doses. So in this case, this open APS technology, it is a combination of CGM as well as insulin pump. So it is a combination of both. Okay, so like monitoring of the glucose levels as well as so injecting the insulin based on the necessity, based on the glucose levels. So OpenAPS is a subset of broader CGM in the cloud social moment. This includes the Night Spot project, which allows CGM users access to their blood sugar data in real time by putting the data in the cloud. And then okay, smart pills. Okay, smart pill. So I came across very interesting things like one of the things this is interesting. Smart pill injects insulin directly into the patient's stomach. So this is called the Soma pill, developed by the Massachusetts Institute of Technology, USA. So in this case, so this capsule contains a device. It has it can inject the insulin, but okay, whatever it is embedded with the small fine needles, which are not harmful. Okay, so when the capsule is taken and it is swallowed, so whenever it reaches to the gastrointestinal system, so there the needle type of devices, they will just inject the insulin into the GAT layers, GAT endothelial layers. So they are not harmful. We don't have pain receptors in the gastrointestinal system. So based on the principle that this technology was evolved, so we need to explore more about this. But definitely this is the principle. So here, particularly this is the technology for diabetic patients. And then smart pill bottle. So this is a technology which also came into the existence. There is a device called Pill Connect. So this is for better medication adherence and remaining the dose and avoid multiple dosing. Okay, so this is an interesting device. So this cap cannot be opened until the dosing time is only during the dosing time, then only cap will be opened. And whenever it is the time for dosing, then it will show the lights are blinked. So when you miss the dose, so then immediately it will send the alert to the physician. So that's how it works. So based on this, how many tablets we have swallowed, the patient has swallowed, and everything data will be immediately sent to the physician. Particularly, this is more useful in case of okay, most of the patients it is necessary for the patients who are taking chronically, and particularly it is more useful in schizophrenia patients. So in case of so there is one drug approved for this. Maybe I am going to show you in the next slide. This is called aripiprazole tablet. So this is the developed. This is developed with the smart pill system. The US FDA has approved the first drug in the US with a digital injection tracking system. So I'm not sure when exactly it is approved, but here the company, the brand, the branded name is Abilify MySite. So it contains aripiprazole tablets with sensor. It has an ingestible sensor embedded in the pill that records that medication was taken. And the product is approved for the treatment of schizophrenia, acute treatment of manic and mixed episodes associated with the bipolar 1 disorder, for use and add-on treatment for depression in the adults. This is the first drug. Even I got surprised for knowing this type of interesting things. So I have been having been more than 15 years experience in pharmacology, but still, so I'm not aware of it. So this is one of the interesting things. And recently, the Massachusetts Institute of Technology, MIT, edible wireless device releases drugs to aid in early intervention. So here, this is a device, like a Y-shaped device. The US researchers and experts from MIT, the Dapper Technology and Women's Hospital, who created an ingestible capsule made with 3D printing technology that relays data via Bluetooth. So after the capsule is followed, it unfolds it through Y-shaped arms and lodges into the patient's stomach, where it can stay for a month. During that time, the capsule collects information about the patient's body and transmits the data to the user's smartphone. And then it can also release the drugs as a response to the detected symptoms. So this is really incredible, very incredible technology. So still, this I don't know. Okay, so this technology already came into the market. As I think the researchers are still doing the research. Created, but okay, we don't know whether it is really. So it was tested in only animals, but not in the humans. So I have not presented here. But this was tested on animals, but had to go to clinical trials. And then, okay, so now I am going to talk more about COVID situation. So in COVID scenario, how these biomedical devices are used for. These are the smart helmet. Smart helmet. So this will capture temperatures using thermal and optical camera. So for example, when you have a huge gathering, okay, so when somebody in front of you already affected with the COVID, so when you wear this helmet, automatically it can capture okay, who is infected, who is not infected. So this can easily identify by measuring the temperature of the body. So it can easily identify the infected individuals with the COVID. So this is another one. Wearable smart thermometers. Okay, so these are all wearable thermometers. So they're very small, like you see watch. So this is called eye fever. So maybe iPhone, all iPhones they have this facility. So if you buy this device, okay, this is going to work to measure your temperature. Maybe yes, okay, it is around the clock, so we can see your temperature. So as long as it is okay, as long as it is on your body. So here, temp drop under ants night. So this is like our temperature recording in our home. So it can also record the body's temperature, but it should be attached to the body. So iSense. So this is also another device. So you can explore more about it. So this is another one. Smart glasses temperature capturing. So these the smart glasses. So when you, for example, if I go to the very close to the huge gathering, and then okay, like more than 200 people, so I can wear this smart glass, and when you look at it, so you can see okay, who are infected and who are not infected in that gathering. So this is a really incredible technology. So we don't know how far it is implemented, in which country it is implemented. So we have no idea. But definitely this is a technology came into existence. Then, sorry, okay. So I repeated the slide. Okay, so these are the drones which are used in COVID pandemic. So we see various types of drones. So here again, this is a drone. It has a technology to record the thermal imaging. Thermal imaging means okay, it can, by seeing the huge gathering, it can identify the people who are affected by looking at, by perceiving their body temperature. So it is quite amazing. And so it has drones have all applications in COVID. So here, this is disinfectant drone. So some of the countries, they use the disinfectant drones to sanitize the areas of the influence, to sanitize areas from being infected with the COVID virus. And then you can see some of the drones which are transferring the medical equipment. So these were used, okay, to carry the medical equipment in emergency areas. And okay, the surveillance drone. So I did not present some of the drones here, but still surveillance drones, as well as they will also give commands. They will announce. So they will make announcements. So whenever they see the huge gathering, okay, large gatherings, so they will they are going to look at the gathering and how many people are okay, maintaining the social distancing. So there are drones which were developed to see after reopening from the following the lockdown. Okay, so after reopening, so the government authorities, they want to check so how many people are really following the social distancing. So those things are monitored by the government officials. So these drones are used. So they are not only capturing them, they are not only capturing the information, they are also announce the people that okay, so you are not supposed to gather, the social distancing need to be maintained. So like this, it will give the announcements also. So easy band processing of tracking with the designated rules. So this was easy band was used in some of the countries. Like Arogya Setu app we used, okay, then some of the apps used in different countries, like selfie app in Poland and other apps, some of the apps in Australia. So here, whoever wears the easy band, so they automatically they can identify whenever they are approaching the close proximity to the infected people. So it will send the alert. So it will clearly indicate, okay, so you are approaching the suspected, okay, infected person. And using this band, whenever these bands are worn by the people, so even we'll come to know. So we'll come to know what is the movement of the infected person throughout the country. So even when they are moving to one country to another country, they can identify maybe. Then there are other medical devices. So some of the countries like I was telling about the selfie app in the Poland. So all the individuals who are coming into the country, they are supposed to be maintained. They are supposed to be maintained in the quarantine. So in order to observe the people, whether the people are following the quarantine properly. So as soon as they get down, they get off the aeroplane. So they will be given one tag. So it's okay. The tag has inbuilt technology of geographic location. They can trace your geographic location. So based on the tag, and they will ask you to install the one particular app in the mobile. So here the facial recognition algorithms and geographic location. Based on these two things, they can easily identify whether the individual is in staying home, they are staying home, or they are breaking the rules of the quarantine. So as soon as the person who is coming out of the house, or who is breaking the rule of quarantine, so immediately they will get the alerts. So there is an option called they can refuse the tag, the application of the tag. But if they refuse the tag, okay, so anytime the police authorities, they will come to your house randomly at any time to check your presence in the house. So it is also one kind of thing. And we have selfie. Okay, selfie option is also they have to take randomly they have to take the selfie and send it to the government authorities. Okay, that's what actually I was misled in the last case. So actually selfie is important to identify the facial recognition algorithms. So using the facial recognition algorithms as well as that geographic location, both are combinedly useful to identify the given the individual person is present in the home or whether he is moving out of the house, something like that. So overall, I would like to conclude. These biomedical devices, they have almost revolutionized the healthcare system, healthcare technology, and they emerged into the various fields, including research, clinical trials, and including pharmacy services, pharmacy management, and then so even I forgot to tell you about education. So in case of medical education or maybe in pharmacy education, it is still not fully implemented, but in case of medical education, already it is being thoroughly used. So when surgeon is doing surgery, so only surgeon can do exactly where exactly he is making the incision and opening it. So he is going to wear some device so that then that can be done, then that can be live streamed into the classroom, or all the students can watch the surgery. So this is how some kinds of smart glasses are used. Some kind of devices are worn by the surgeon. So they are directly classes that can then directly live casted streamed to the classroom. So this is one application I know, but there are many applications in the education system also that you can explore more about it. So this technology has really amazing technology. So still I did not mention about artificial intelligence and then robotic technology, even machine learning. So I hope the other speakers they are going to cover all these things. But first of all, I would like to appreciate organizers. So particularly Dr. Manjari Pawar Madam for taking initiation, and this is a Herculean task for talking to these many speakers, and particularly these topics are very difficult to cover because we need to identify the experts all over the world, So that too, these are all the areas which are coming up. So particularly for artificial intelligence, the technology itself it is evolving out. So the expertise, the people who have expertise also very less. So finally, I would like to conclude, and then these are my acknowledgements. So anyway, I express my sincere gratitude to Honorable Vice Chancellor, Professor PVJD Prasad Reddy Garu, and the Honorable Registrar, Professor V. Krishnamohan Garu, and Honorable Rector, apologies for the Honorable Rector, Professor K. Samata Madam of Andhra University for giving me the opportunity to be a resource person in this faculty development program. So I also express my sincere gratitude to the Honorable Principal, Professor Vairendra Prasad Sir, Andhra University for giving me an opportunity to deliver a talk. So I sincerely also thank Coordinator Dr. A. Krishnamanjari Pawar Madam for her effort for making my talk a reality. So I thank my supervisor, Dr. Krishnakumar Veervalli, Assistant Professor, so in our university. So he supported me well for this presentation, so he guided me. So during the process of preparation of the presentation. And finally, I dedicate this presentation to my guru, Professor Akul Annapurna Madam, Professor Andhra University, who shaped my career to reach the current position. So I am proud to be a resource person, okay, where in Andhra University, because okay, that is the university where I graduated. So I am more humble and more respect. So all my gurus, I respect all my gurus in Andhra University. Thank you all.
Thank you so much, sir. Now I request to the delegates to please clarify your doubts. Sir.
Okay, I'm going to try to page. Okay, can I stop sharing?
Yes, sir. You can close your presentation.
Okay.
Dear participants, now the session is open for the discussion. Sir, from Arun Kumar, Vijayalakshmi Garu, excellent presentation, sir. There is a feedback for our session.
Thank you. Thank you.
It is an informative session. Anita Singh, Nagarjuna Garu, excellent presentation, sir. I request the delegates, if you have any queries, kindly unmute yourself and discuss with sir. Now the session is open for discussion.
Am I audible, sir?
Yes, yes.
Yes, sir. Please go ahead.
So you have mentioned one device in that Y-shaped wing will be opened. It will retain the delivery system for 1 month. So can you tell what is the mechanism to retain the system there in the stomach for 1 month?
Yeah. Okay. So I don't know many details about it. So we need to explore more. So you have details in my presentation. So you can, if you never mind, you can go through it.
Thank you, sir.
Any other participants, please? Yes, sir. Thank you so much. So, dear,
you can share my presentation, whoever wants it. Maybe I want them to explore, okay, wherever it is not elaborately explained, so they can just copy it and Google it, so that they will come to know many facts about it.
yes, sir. Thank you, sir. Dear sir, Dr. Shiva Reddy Challa, we are very happy to hear about the bridging of the medical technologies with Internet of Things. Your lecture helped us to boost our knowledge and was very fruitful and knowledgeable to all the participants. In your lecture, you discussed on the various aspects of Internet of Medical Things like statistics, market value of the medical technology, classification of Internet of Medical Technology, benefits of Internet of Medical Technology, challenges in implementing the IOMT, emergence of IOMT into different health spaces with various applications and examples like AccuVein blood for blood sampling, artificial pancreatic system, smart pills, edible wireless devices, smart helmets, wearable smart thermometers, and smart glasses for capturing the temperatures, various drones used in COVID pandemic, easy band processing of tracking with designated rules. We are extremely thankful for investing your valuable time in enlightening the topic IOMT. I know the clock might be showing midnight there. We can understand your interest, patience, and zeal towards the profession, and we are so happy to be associated with you always. Thank you so much, Dr. Shiva Reddy sir.
Thank you, madam. Thank you for your kind words.
Thank you, sir. Now the session is over. You can leave the session, and we will be rejoining the session sharp at 3 o'clock. Thank you so much. We'll be waiting for you for the third session, dear participants. Thank you.
Our session will be followed at 3 o'clock.
Dear Dr. Sampath, I request to keep your mobile in mute. Thank you so much, dear participants. You can have your lunch and come back at sharp 3 o'clock. Thank you all.